Good morning, good afternoon, good evening, based on the time zone you're joining us today. My name is Victor Monga. I'm serving as Vice Chairman of the board. For those of you who might be interested in learning more about me, please connect me over LinkedIn and or Twitter. Virtue Testing is a California incorporated organization. It's a 501c3 tax-exempt nonprofit. That means all donations paid to VT are tax deductible. VT was founded on simple concepts like curiosity and community. We service 3 centers of excellence. Education is to offer the community to speak, collaborate, hands-on learning, and grow. This helps our community members to amplify their skills to advance their professional careers. Charity is to offer fiscal sponsorships to groups and missions who do not have non-profit legal status. We enable them so they can start accepting tax-deductible donations without having to build and maintain non-profit legal status. Innovation is to work with our partners to crowd test new security platform integrations. We believe state-of-the-art technology can and should be accessible by anyone. We build partnerships with other organizations to collaborate and enhance experience for our members. Yeah, let's talk about the slides, recording, and certificate of completion. How are you guys gonna get it? You are not, I'm kidding. So slides will be posted on our same events page. I'm gonna post it in the chat as well right now. Recording will be posted on our YouTube. Links will be available at the same events page, and certificate of completion. People who needs it, please send us an email to contact@virtualtesting.com. Once again, all of this information I'm gonna post in the chat right now. So people who would send us information that you need certificate of completion, please provide us with your full name that you want us to print on certificate. So once again, that's an email for certificate of completion. That's the link that you all hopefully got to subscribe. That's how you guys got here. So if you pick up your smartphone, scan that QR code, it's gonna point you to our LinkedIn, Twitter, and YouTube so that you don't have to memorize all of those funky URLs or any email addresses or anything else. This will point you to exact those links that I just mentioned. All right. So today's agenda is going to be quick intros about virtue testing, about partner, our speaker, our topic. From there, we're just gonna jump right into it about Linux and its commands.
I want to mention a couple of things here before I get started. First, I want to thank Virtual Testing, CSA, Victor, for having me back again. Always enjoy sharing the stuff that I learn and the mistakes that I've made, so hopefully others don't make the same mistakes and get to a better place faster. It looks like we're still going to post those things in the chat. I got a couple of questions there, Victor, about the slides or the instructions. So we'll get those to you in just a second. About the company I work for Richie May Technology Solutions. It was traditionally a CPA firm. It's been around for a long time, but in the last couple of years, it has transitioned into a business advisory firm. 2018, they brought me in, as well as 2017, they brought my boss in to build up a cybersecurity practice. So while the company's old, our team's a bit new, but we've got a lot of experience in the industry. Prior to joining Richie May, I had a boutique cybersecurity firm here in Los Angeles, and it just aligned with what Richie May was doing. And so they ended up acquiring my company, my team, our clients, and it's been happily ever after since then. So just want to give them credit and appreciate that they give me the opportunity and the time to take the time to share some of this stuff out of my day. And a little bit about myself. I have been in the industry for probably going on 15 years now. I already talked about prior to being the director here at Richie May Technology Solutions. I was a DoD contractor, so I would teach courses. I built some of the ethical hacking courses for local Navy bases, DoD, DOJ. I volunteer with the Marines in their Cyber Auxiliary Division. I teach at local colleges here in Los Angeles. So if you've attended CSUN or Moorpark College, I've developed and still teach some of those courses from time to time when I can. I also, here in Los Angeles, most of our office at Richie May is in Denver, Colorado. So I head up our Los Angeles office here, and I get the pleasure of working in the entertainment space. So prior to that, I was doing a lot of cybersecurity, offensive and defensive, in the financial sector, but I started getting more and more clients in the entertainment space. And so Richie May was also focusing on that. They ended up just putting me in charge of the media entertainment division. So if you're in that industry, I'd love to talk to you after this. I'm a certification junkie. Lately, it's been a little bit slower since I had a kid, and I now need a little bit more sleep than I used to. But I used to sometimes do about one certification a month I'd go out and get, and now it seems like a couple a year, and they're a little bit more focused and targeted. A lot of SANS and GIAC training that I've been doing kind of lately, and then some of my own research and projects and kind of steering it in a different direction there. So that's about me. I'd love if you connect on LinkedIn, Twitter. I try and post as much as I can about events that I'm free workshops, talks that I'm giving, projects, white papers, whatever I can kind of give back. So if you connect there, it's easier to get a hold of me there than email, since I can't seem to get less than 100 unread messages in my inbox. So that's a great way to get a hold of me if you want to collaborate, communicate, ask questions. I frequently speak with colleges and cohorts in cybersecurity and give them tips, advice, career stuff. So happy to communicate on any subject cyber related, or kids if you'd like that too, since I've got a little guy here. So without further ado, let's talk about some of the learning objectives for this workshop. And I do also want to mention that this workshop is the second time I've given it. The first time it was 4 hours, so I'll see if I can speed that up a little bit. And the first time I gave this, it was junior level, and so I'll try and speed along a little bit on the intro stuff, and hopefully we can get through a little bit more of the labs on this. So the learning objectives are, and really the reason that I developed this course was that even on my own team, we get junior level security engineers or analysts that would come in, or when I would talk to people at conferences, I realized that the newer people in the security industry didn't have the same background that some of the veterans had with Linux. It seems like if you talk to any veteran cybersecurity person, they would say, well, I grew up on mainframes, or, I've compiled my own Solaris kernels and all that kind of talk, and you just kind of roll your eyes at them. Well, that gave them a foundation that I think a lot of the newer security analysts and engineers just are not getting, just jumping into Windows and taking some of the courses. I mean, even when I went to college, I think it's coming up on my 10-year anniversary for my master's degree. And there was not a single cybersecurity program back then that I could find. Even in my bachelor's, I ended up getting a dual bachelor's. One was in business strategy. The other was in computer information systems. And even to find a computer information systems degree, not a focus within a business degree, but its own degree, there was only about 5 of them that I could find throughout the country over 10 years ago. So there's a lot that's changed. I think it's just a difference of we've kind of banged, or as veterans have banged our head against the keyboard and had to deal with Linux. It was just part of the job. Whereas the next generation of cybersecurity professionals didn't have that, and you're somewhat lucky, but we also don't have some of those skills coming into the workforce. So there's a lot of stuff you can do with Linux. I'm sure there's other ways to do it with Excel and other tools you can find on the internet, but Linux does have some really cool features that can make your job as a security analyst or engineer a little bit better. So we're going to learn about what options are available to practice command line usage after this workshop. We'll learn about how to keep Linux systems up to date and patched. We'll learn how to identify common security misconfigurations, learn how Linux can be used to automate common cybersecurity tasks, learn how to parse log files for useful information, learn how to manipulate large amounts of text efficiently, learn some basic regex and what that is and some of the power it has behind it, and then learn how to install useful software on Linux. And then finally, hopefully we'll get to some for loops, which I have a lot of fun with to automate some tedious tasks. Okay, Linus Torvald, creator of Linux, says here that the Linux philosophy is laugh in the face of danger. Oops, wrong one. Do it yourself. Yes, that's it. The importance of learning Linux. So I already talked a little bit about this, but I feel like there's many use cases where you may be able to do something with Excel or Windows machine that you're working on, but there's just so many cases that you can just scale and automate things using Linux. One example I have is that I was looking at a spreadsheet the other day Long story short, I was working on a client's project to get them better alerting and logging with their SIM. And what I was trying to do is I wanted to correlate their DNS lookup. So every time a machine asked the question of, what's the IP address for google.com or facebook.com or whatever domain, that list of domains that was queried within their environment would then be, there was way too many. There was, millions of these happening per day. So the way I was trying to filter that out and get more useful data for the client was that I download the list of the top 1 million domains. It used to be the Alexa top 1 million. Now it's the, I think, Majestic million. And I wanted to then have the SIM go and look up those domains and say, every time I have a query, go look there. And if it's on that list, don't show it in this view. But if it doesn't meet that criteria and it's not on the top 1 million domains that are used in the world, then I want to see that in my log files. And so it was a way just to filter things out, because the chance of malware coming from Google or from Facebook or Instagram is a lot lower than it's coming from x5z4y73.com that was registered 20 minutes ago. So I was using that, but the long story short of this is that it was a 1,000,001 rows within Excel. And I accidentally opened it in Excel. And even my brand new Mac that I have in front of me that's got a terabyte SSD, it's got 16 gigs of RAMs, it's got an i7 Intel processor, 8 cores, all this stuff. And it froze Excel and my whole computer started going crazy. So I wasn't able to open that. I had to force quit it. I had some other problems after that. I made that mistake of trying to open 1,000,001 lines in Excel with a brand new computer, and it still had a hard time with that. Now, I was easily able to use Terminal or Linux instance, and I was able to parse that information, open it up, look at certain lines, query things from it with no problem whatsoever. Also, that patching is one of those things that's often forgot about within Linux. Late last year, when we were able to travel, I was in another state visiting a client who wanted to do a maturity assessment, a cybersecurity maturity assessment. And I spent the week out there, and I was looking at their patching, I was looking at their EDR, I was looking at their SIM, I was looking at pretty much everything, even physical security and how their security guards handled me when I came in the door. And throughout that, their patch management, they had a pretty good handle on it. They talked about, when I asked them about it, they said, we've got this tool and that tool for monitoring patches, and we have exceptions and exclusions when this doesn't work out or we can't patch, and so on and so forth. It was all great. And then finally, at the end of the interview, I said, do you have any Linux systems? And they said, we've got about 15 Linux servers. I said, great. So these are patched with the same procedures you just talked about? And they said, no, that's different. It doesn't really work with that tool we have for patching. Okay, so it's manually patched. Yes. Okay, so you've done patching within the last 30 days. Nah, probably not. 60? Nope. 90? Probably closer to over 100 days was the last time they patched those Linux systems. So even in large enterprises, it's still often forgot about, and they're left there sitting in the corner. The other reason we're going to talk about Linux is that even if you say, and you may be naive like I was when I started out my career, and say, well, I don't use Linux, my office doesn't have Linux desktops or servers, we're a small business, this isn't really relevant to me. Well, what about the website that your company is using? If we look at this chart here, this is as of April 2020, and it shows that depending on the number of pages and sites that you have and volume there, but you can see that Apache and Nginx, which is running on Linux, those are still some of the top used out there for websites. So chances are, if you have a website, your company does, to some degree, have and need to maintain Linux systems. I challenge you, if you also think that's it, go out there and look at everything from when you get back in your car and drive it. What do you think your infotainment system in your car is running? It's running a Linux kernel. What do you think your router is running under whatever it is, whether it's FortiGate or SonicWall or Palo Alto? Under that, it's a Linux kernel. What about your phone? If it's an Android phone or if it's a iOS phone, you're still running some type of Linux or Unix kernel. All the things throughout us, my Nest thermostat that's sitting in my house is running Linux or Unix kernel. So it's all around us. And I didn't really see that early in my career. I had a mentor come to me and tell me, you need to learn Linux. And I kept saying, no one uses it, or clients don't use it. And he ended up showing me how he was an offensive security professional, a pen tester for the Department of Defense. And he went into a secure facility where they did a lot of things right. But one mistake they made was that the Coke machine in the lobby was plugged into the secure network. And it had, of course, the person who maintains the Coke machine, the vending machine in the lobby, was not patching the software or even Linux by itself. And so what happened is that he was able to find that Coke machine was scanning the network. It was probably years out of date since the last update, and compromised the Coke machine, installed tools there, and then pivoted over and attacked other machines because the Coke machine was unpatched. So Linux is everywhere, right? Here's just a demonstration. Again, your Nest thermostat's running Linux kernel. If you've got a router, firewall, even the Mac that I'm on right now, it's running, underlying, it's running FreeBSD. Android, if you've ever flown on a plane, hopefully we'll get to do that again. Those infotainment systems in front of you, I've seen them reboot and you get to see the penguin there. It's running Linux. Your smart TV, your car, everything. So how do we practice this? And this is a great start by coming to the workshop and learning this, and hopefully you continue to use Linux. But I find making it more convenient will help you as well. And so back in the day, you had to format your computer or dual boot, and it just really wasn't that convenient. Nowadays, you have a whole lot of additional options that you didn't back in the day that will help make this easier. And I really encourage you to try and do more and more tasks in Linux, because it's similar to you coming to me and saying, I want to learn how to drive a stick shift car, a race car. And I say, great, I'll teach you the basics of how to drive stick shift. But then after an hour of driving that, you're like, kind of got the hang of it. I stall it once in a while. I'm pretty rusty. And then you go back to your automatic car. Well, you're probably not going to be the smoothest, best stick shift driver after going back to your normal car. However, if I lent you a car, I don't have one right now, but if I had one that was a stick shift and I let you use that for a month or 2 months, and then you came back to me, I bet you would be pretty good at driving stick shift. So I do encourage you to make this your primary vehicle for a few months. Work on it. You'll bump your head into a lot of things. It'll be a little bit painful, but you'll get a lot better at it if it is your primary operating system. So my goal is to make this easier for you. A couple of ways. If you just can't ditch Windows, Windows subsystem for Linux is incredible. It is just sitting there just like an application like Outlook or Word or OneNote or whatever tools you have on your computer. It can just sit there, and at your beck and call, you double click on it and immediately have access to Linux there. So that's probably the easiest way. And then Microsoft has just come out with Windows subsystem Linux 2. And that has additional capabilities. I haven't got my hands on it yet, but from what I hear from other people in the community is that it's phenomenal. And then you can also virtualize. So if you have VMware, VirtualBox, Hyper-V, there's no excuse for not having a hypervisor on your Windows system. If you're running Windows 10, it comes with Hyper-V, and you can easily install Ubuntu there. So you don't even need to add anything in. If you tell me that your organization doesn't allow you to install VMware, well, you've got VirtualBox sitting there. Hyper-V. You've got, you can install it on an old laptop. So it's slow. It's a bad laptop. Maybe your kid uses it. Well, install Linux there. Make your old laptop that computer, and that's your web browsing computer, or make it your computer that does mobile banking or just reading or something, but give an old computer use by installing Linux on it. And then you also have the ability to have on-demand servers in the cloud. So AWS, GCP, Azure, Alibaba, whatever cloud platform you want, you can easily spin up Linux instances for more of public use and testing. So you can have honeypots, you can spin up web servers, you can do, it's unlimited there, and it's so easy. I remember the first time I tried to set up a Linux cluster, and I spent 2 full days, a Saturday and Sunday, with a friend and 4 laptops trying to set up a Heartbeat and high availability. And after probably about 20 hours within a Saturday and Sunday of doing that, we just gave up on the project. But now within seconds, you can spin stuff up and have that at your fingertips. And then obviously, if you do have a Mac, you have Terminal. I just noticed my new Mac that I just got, the default browser, but shell is ZSH, but you could obviously switch that over to Bash, so it's a little more familiar or similar to Linux, but you have that if you're running OS X or a Mac computer.
We're going to have a session pretty soon where we're going to show how to use AWS free tier to set up a honeypot. So stay tuned for that.
Wonderful. I'd love to attend that too. I've got, just before this workshop, I was working with one of my engineers. We're setting up a couple of different honeypots for a future workshop and a talk that we're going to call I Got Hacked on Purpose, and Here's What I Learned. So you can learn a lot. I encourage people to join that that talk. Hopefully I can make that one as well. And then, so what I decided to use for this, I went back and forth on what infrastructure I wanted to have for this workshop, and ultimately decided on Mint Linux, which prior to building this workshop, I had not used personally. Traditionally, I've been a pretty big Ubuntu fan. The reason I selected Mint is, one, I could get the footprint a little bit smaller. Two is, from what I was reading, is that I wanted to make this really user friendly, and a lot of people were saying that Mint tends to be an easier transition from Windows than Ubuntu is. And so I could kind of see that, and I started playing around with it, and I started liking it. I liked some of the features they added into it, and also number of downloads is really high. The minimum requirements were a little higher than I wanted. I did play around with doing a light version of Ubuntu, but it was less user-friendly. So ultimately, again, we went back to Mint Linux here. So you need at least 512 megabytes of RAM. I was able to install it with a minimum of 11.7 gigabytes worth of hard drive space. They say you need some type of CD or DVD port, or even USB. And then 800 by 600 resolution. So if it's an old computer or monitor, it should be easy to install on almost any old device. And you can see there's plenty of distributions if you're new to Linux. Unlike Windows, where we just have really like Windows 10, with Linux, there's many different flavors, I'll call them, or distributions, and they have different pros, cons, features, backgrounds, ways of interacting it, user interface. For example, if you're trying to do penetration testing, you're probably going to use Kali Linux. If you're using something defensive and you're trying to monitor your network, you might use Security Onion. So they're basically Linux distributions that are tailored for a certain use case. And so as you can see here on the left side of the screen, the hits per day, if we look at, I don't see the date on here, but this was when I was first building this workshop, so probably April this year, that Mint Linux is one of the more popular ones up there. Okay, and so the lab environment here, this is something you probably want to screenshot, keep up. These are the usernames and the passwords of the different users on the system. So I've got 3 users. You've got the Mike Wiley, which is going to be your primary user that you use for almost everything. That's the one I want you to log into. The password is just Linux, all lowercase. There is 2 other users that I did a couple of things with. We've got just a regular user. So I added another user as the standard user level, not an administrator, just standard user. The username is user1, password is user123. And then with the sample admin, I just did user1_admin. And so it's the same thing. It's just a regular new user I created, but I gave them administrative privileges. And the password, it wouldn't let me make it simple. So I had to make it a little bit longer of the Mike Wiley. And so those are going to be your 3 users, and we'll go through those. So just keep those handy. We'll come back to those, and I'll try and display that again when we get into the lab environment there. That being said, you should have seen in the invite or one of the emails that was sent out, you should have the download for our Linux distribution, and there is also a lab instruction guide. And so I'm just going to look at that real quick. It kind of tells you the minimum requirements of what to have. I say Windows laptop just because I don't want to have to troubleshoot VirtualBox or Fusion on a Mac. Obviously, you can do that yourself, but it's set up and it's real easy user experience if you just use a Windows laptop with VMware Player. Make sure that virtualization is enabled. You might have to go into the BIOS and turn that on if this is your first time using virtualization. I recommend using 7-zip to extract it. There's less errors that way. So if you go download 7-zip and then extract the VM that way, the default Windows Explorer to extract zip files, it sometimes gives errors because of the size of the files. So you just have a better experience if you use 7-zip. And then I give you some steps as far as how to extract that. If you get an error that says there's a compatibility or consistency error, just press retry and that should work. If you have any other issues outside of that error, please let us know in the chat. And then I give you the basic credentials there as well. Okay, back to some Linux terminal tips and tricks here. So you're going to see throughout the slides that I have in brackets, square brackets are going to be options. So for example, if I say run the command ping And then I don't want to just say ping and then leave you hanging there. So in brackets, the square brackets, I'll put 8.8.8.8, or I'll give you some instructions, but anything in square brackets, that lets you know that that's something that you need to enter or change or add to, whether it's a port number or an IP address or an option, something there that you're going to have to add. When you see the font, and hopefully this transferred over, but the Carrier new font, it's a little bit more, it stands out, and you'll see that that's supposed to be a command you're going to type in. So if you're not sure if I'm talking about who am I and I'm confused at who I am, well, look at if it's in Courier new font, and if it's in that font, I'm talking about the command, not questioning who I am as a person. So that hopefully will give some context. And then throughout the slides as well, typically, and I'll see how this kind of ported over since we moved to a different template here, but if you see a $, typically that means I'm running the command as a non-privileged user. So that means like your standard user one, they don't have administrative or root level permissions. Now, if I have the pound sign or the number sign, it's going to basically mean that you're running that as root or privileged. And so if I don't have sudo in front of that, so if I say type out a command and it's got a pound sign in front of it and no sudo, it means I'm assuming you are running as a privileged user. And if you're not, you might have to write sudo in front of that if you get an error. Okay, and then so here's a couple of tips and tricks that have helped me out, and this is something that you can kind of keep as a cheat sheet. You can put this later on in maybe a OneNote or Evernote or however you're documenting this stuff. But in the beginning of this workshop, so once you get into your virtual machine there, what I recommend you do is type out script and then, for example, workshop.txt. And so if you type that out, what's going to happen is that it's going to record everything that you type throughout this session. And so the beauty of this is that when we're done with the workshop in a couple of hours from now, then you type exit, and all the commands you typed into the command prompt and the output and everything will then be saved into a file for you to look at later. If you forgot the command or you did some stuff playing in the lab that wasn't in the slide, you're going to have a copy of everything you typed out. The other thing I'm going to give you a tip is when you are in terminal there, if you are pressing up arrow on your keyboard, so the one that's just to the right of your enter or just below your delete sign, hopefully on your keyboard, if you press the up arrow, you can scroll through the history of your commands. So for example, if I typed who am I, and then script, and then ping, and all these other commands, and I wanted to go back to who am I could press up arrow once, twice, three, oh, there it is in my history, and then I can just press enter. So you don't have to retype out the commands. This is especially useful if you make a mistake or an error. You just type up, and then you can go back, and you don't have to retype everything out. The other thing that you could do is if you press the exclamation point twice, so exclamation point, it'll execute the last command you entered. So if you type something like ls or dir or something and you want to do it again, you could just press exclamation point, it'll execute it. Other option is you press up arrow and then enter. Both of those are 2 things long. The other thing that's really useful is a lot of times I'll type a command like use nmap or a tool that requires elevated permissions, and I was a regular user. I'm going to type out this long command, and then it's going to say, sorry, you don't have permissions to access that file. And I'm like, oh, shoot, now I got to retype this whole thing out. Well, the trick is just type sudo space exclamation point, and it'll run the last command as elevated permissions. So it'll run sudo and then the last command that you wrote. Save you a ton of time. The other thing you can do is that you can type one exclamation point and then some type of string or some type of keyword that you've used in the history. And then what's going to happen is that Linux is going to go through the history and it's going to look for something that matches that. So maybe it was 100 commands ago or 50 commands ago, and you don't want to have to scroll through it all. Well, you could just type exclamation point, who am I, or who, and then enter, and it'll go try and search through your history and execute that command. So I know these are a little bit more advanced, but those of you who maybe have a little familiarity of Linux, these will help you as shortcuts. If you have no idea what I'm talking about, that's fine. You'll come back to these later on. I want to also show you as we go through some of this stuff is that redirects. So if you see me use a caret or what looks like an arrow pointing to the right-hand side, that is going to be, I'm redirecting the output. And so what happens in Linux in the command prompt is that when I type a command and it goes into the computer system, I'll call it, then there's going to give me feedback back to me. And by default, it's using, on my standard out, it's using my screen. So the default behavior is that if I ask a question like, who am I? And the computer then responds back to me with, you are user one, right? That output, that user one is the standard output that's being put out through my monitor. What happens though, that's great most of the time because I want to see the answer. If I ask, who am I want to know the answer to that. However, there may be times when we want the output not to go to the screen, but go to a file. And so we can use the shorthand of a caret or an arrow that's going to the right. And what that's going to do is redirect the output that would have been on the screen. And instead it's going to dump it into a file, for example, list.txt. So I can then use the ls command to list everything in a directory. And instead of it being on the screen, it's now going to be in a text file called list.txt. And I'll show you a demo of this later. The other thing that you can do is if you add two arrows or two carets pointing to the right, that's going to redirect the output or the standard out of the command. So if I ask, who am I, or ls, it's going to respond back and it's going to go into the text file. Now, the difference here, though, is with the two carets or the two arrows is that in the previous example, it's taking all the output and it's overwriting everything in that list.txt file. If I use two carets or two arrows to the right, it's then going to append all that information to the bottom of the file. I'll give you a demo of that in a little bit. And then the other useful thing is that use tab complete. So if you're trying to type out a file path or a name of a file or many other things that we're going to be doing, when you can, try and press the tab button on your keyboard and that will autocomplete. And especially when you're talking about file paths and file names, that will save you a lot of headache when you mistype something because Linux is case sensitive. So when you've got something that's case sensitive, unlike Windows, if I type C:\users user1 desktop, it doesn't matter if it's uppercase, lowercase, or a combination, it's still going to find that file path. So the difference though is that with Linux, if I type all lowercase desktop, it's not going to find it because that doesn't exist. I have to type a capital D and then lowercase ESKTOP, etc. And so it is case sensitive. And by doing tab, it'll help us from making mistakes. A couple more tips here. The other thing we can do is use a pipe. So that's going to be probably above your enter key if you press shift and then the button above your enter key, depending on your keyboard layout. That is going to be used to pipe the one command into another command. So when we use the carets or the arrows where it was taking the output of one command and putting it into a file or redirecting the output, if we use the pipe, what's going to happen is that we are going to take the output of, let's say, who am I? And it's going to answer that. The answer is then going to go into another command like, I can't think of a great example with that, but it's going to, then I can run another command like grep or t or some other command. So I can chain commands together. And again, it'll make more sense when I do a demonstration.
Logging, when we search logs or something filter.
Yep. Yeah, and in my who am I was a horrible example, but absolutely when we get to the log analysis, you're going to see we're going to use something like cat to display out the contents of a file, but it's going to be, let's say, 100,000 lines long, and you're not going to want to look at all of that just fly across your screen. So I'm going to pipe the output, which is going to be the 100,000 lines of my log file, into another command, like let's say grep, and grep lets me do something like search. So I can search for a keyword like Metasploit, and then that's going to filter it down or narrow down our results to 1,000 results. And then I'm going to pipe that output to a command like cut, which lets me dissect the logs and look for certain pieces. Again, it might sound crazy right now, but we'll go through a lab and I think it'll make a lot more sense. I'm just trying to show you what these things are, like a definition, and then we'll get some hands-on practice. What else can we do? And then the other thing I'm going to tell you is that if you're stuck, absolutely go out and use Google, use the man tool, use help. Some commands, if you type the command and then -- help, it'll give you more help for there as well. But don't be afraid. I don't know everything about Linux. I'm actually a horrible Linux administrator, but what I do know how to use is I know how to use this tool, which is Linux, in a very sniperish way. And I use it for a specific purpose. And so that's kind of what I wanted to tell you. The disclaimer is that if you ask me some obscure Linux question, how to compile your Linux kernel, I am not the person for this. I'm just showing you how it helps me complete my job as a security professional. And in that being said, I almost every day using Linux have to Google, well, what was that command? Or Regex, I cannot remember every regex expression, so I have to go out there and use tools to help me. That is totally okay. We all do it. I use the man page, the help tool, all these things frequently, and I encourage you to do so as well. It's a self-help tool. Okay, a couple more before we start diving in here. Some other shortcuts. Again, if you're new, forget about the shortcuts. But if you have a lot of experience here, you're going to notice that, especially in the VM, if you press Control C like you normally would in the terminal, it's not going to copy and paste. If you type Control V, it's not going to paste quite right. You need to do Control Shift C for copy and Control Shift V if you want to paste things. Alternatively, you can right click and it will also paste as well. If you press Control and then the left arrows on your keyboard, or Control and the right arrows on your keyboard, it'll help you move to the start or the end of the command that you're typing out. So let's say you typed out a long command and then you realized, oh, I need sudo in the beginning, or I missed something, or I did a typo at the beginning of my command. You can hold down the Control key and then your arrows, and it'll help you get there faster instead of one character by one character going, left or right on your keyboard there. The other thing I like to do as well is you don't have to just type one command at a time. If you want to, a great example is you want to create a new folder or directory called example1, and then you want to move into that directory, you could type make dir, which is make directory, and then folder one. You've created that. Now you type cd folder one and you move into that. You could absolutely do that, but there's certain cases where you may want to have one command that does multiple actions. So you can use the 2 ampersigns and between those commands. And so if the first one succeeds, it's going to go ahead and then execute the next one after that. And then if you press Control C, if you ever get stuck in a loop, like let's say you ask to cat out 1 million line spreadsheet or a CSV file, and it's just flooding your screen and it's going to take a long time, go ahead and press Control C and it'll escape out of the command that you've got yourself into. There's a question about using VirtualBox instead of VMware. Yes, you can. However, it is formatted as a template for VMware. So those using VMware, you can easily go ahead and just import it and you're good to go. If you're using VirtualBox, I think you can only use the virtual hard drive, the VHD. You don't want to use the template that I've created. So you're going to actually have to create a new shell, give it the similar amount of RAM and stuff like that, and then you can go ahead and attach the VHD. It's a little bit more of the steps there. So that's why I say make sure you've got a Windows machine and VMware player or workstation, because it would be seamless. If you want to play with VirtualBox, we can try on breaks to help you, but it's just not supported because we've got 93 people and it's got to work smooth here. Okay, so I do want to show you a little bit of this. I'm going to talk about I'm going to switch back and forth between the Linux instance here and kind of give you a demonstration, but these are how the slides are going to be laid out. You're going to have, at the very top, I'm going to talk about what command we're talking about. And then I'll give you some bullet points about what the command does, maybe how to use it, some options. And then at the very bottom, I'll give you an example or demonstration there. So you can see at the bottom, I have in the box, man ls, and it shows you the usage for that. So I am going to switch over here to the Linux box and just kind of walk through these and show you. Give me a second here. So I'm getting into this with the password of Linux. And we can see here that, let me actually shrink this a little just because I'm missing the bottom half of the screen. Okay, and you can see it's a little bit different than Windows, but I do like that Mint here that you've got the start button in the bottom, and it almost resembles a Windows 10-ish style menu, and you've got your taskbar at the bottom. Our time is at the bottom. It looks very similar to a Windows environment, whereas Ubuntu is a little bit more a mix of maybe OS X and Linux-y Windows. They have their own flavor. It's great. I just wanted something that was very familiar to you. Okay. You've got folders like your home, you've got your desktop here, you've got Firefox, you've got everything you really need here. But really we're going to focus here in the bottom. I've got the terminal. I'm going to open this up and this is what we're going to focus on. The other thing that I have here is that I changed the command prompt for you a little bit. So typically you've got the user you're logged in as, and then followed by an @ and then the machine name and possibly the directory structure, but that ends up being like way out here when I've got this blown up, and then you only have a little bit of space there, which is unfortunate for demonstrations. The other thing I don't like is when you're new to Linux, I don't like you to see the path that you're in, because I think you get to use it as a crutch. So what I like to do is I have no idea where I'm at, which encourages me to use commands like present working directory, which then I have to find out, oh, this is where I'm located. And it gets you thinking a little bit more in the Linux mindset here. Okay. So I'm going to type clear, and you'll see me do this a lot. This just clears my screen to make it a little easier for you to look at. Let me see if I can even make this a little bit bigger. No, we're fine. Let me know if you need me to make the font bigger. I think this should probably be good for everyone's screen size, but if that's not the case, let me know and I'll make it a little bit bigger. As we go further on, I might have to shrink the font size just because the commands get longer and it's hard to read the output here. But so the first command I wanted to tell you about is man, and this is one you're going to come back to time and time again. So the example I have here is if there's a tool you're using like ls, and you say, I don't really know what this tool does. You know, I type ls and I don't know what this is. So the thing that we can do is we can use man, the manual tool, and then the command that we want to learn more about. When we do that, it's going to give us this output and say ls basically lists directory contents. You would type ls followed by some options and possibly a file or path. And then it gives us all the other, what is this here? All the other options. So you can see A for all, we can see B to print blah, blah, blah. And we just kind of go down here and see other options that we might want to use. The other thing you can do is put a // here as a tip. And if you're looking for, let's say, hidden files, I can type out hide or hidden, and then it almost acts like a search function. If you just do a / here and then the keyword you're looking for, and it'll try and find that. When I'm done, to get out of this, I just press the Q key as in queen, and I'm out of that, right? And so I can do this for many things. I could type man cat, and this talks about the cat tool, which is concatenates files, prints out the standard output. It gives me all the options. I'm using my up and down arrows on my keyboard to kind of scroll around and look for what I'm interested in. I'm going to press the Q key to escape out of that. Okay. Similarly, some tools, if I'm working on, let's say, cat, I can type out -- help, and it will also do more of an abbreviated version. I prefer this if the tool writes this. It's up to the tool creator to write their own man page and help and stuff like that. So results may differ, but this is definitely helpful to look for what you're interested in for. Okay, clear that again. On my slides, I'm going to move on, but I'm going to keep this here on my screen just so you can see. I'm going to keep the VM up so you can kind of see a real demo rather than just look at my slides. So the next tool I want to talk about is the apt tool, which stands for Advanced Package Tool. And this will help you avoid outdated packages by updating them before upgrading them. I'm sorry, updating your repositories before upgrading them. And so what we can do here is to see a list of available updates. Now, please, please, please don't do this until after the workshop, just because I want everything to work the way it does in the staged environment. But this is essentially, you need to find out what updates are available. So what I would do here is, and I do need to use the sudo to elevate my privileges. And I'm going to actually show you what it looks like without doing sudo to elevate my privileges. I'm going to type apt get update. And what's going to happen here is you're going to see it says, could not open locked file, permission denied. And this is because I tried to run this as a standard user or just not as a privileged mode. So what I'm going to do, clear the screen, is I'm going to type sudo, or remember what I taught you, if I type sudo ! That'll allow me to run the last command, which is if I type the up key or up arrow, we can see I can scroll through my history here, was this command. And now I can go use my arrows and go all the way to the front and then type sudo here, but you could see that could get time consuming. So the other option I have is I can just type sudo ! And it's going to run that last command as sudo. It'll ask you for the password because I'm in the sudoers group. I can go ahead and type Linux. And again, please don't follow along with that piece. What happened there? Sudo apt get update. There we go. That's what should happen. And it's going to update these repositories, right? And I just don't want you to do this yet because it may cause some issues. And I just want everything to work the way it did last time I taught the lab. Now, when it's done, all these updates are available. We could go ahead and do this, which I'm not going to go ahead and run, but sudo apt get upgrade, and this is going to go ahead and upgrade any of the packages or software that we have on the system. So these are doing like, imagine your Adobe updates that you see all the time. This is equivalent to that, and this is what a lot of people are not doing. I don't want to update this just because, again, I want the lab to work the way it did last time. If you were going to upgrade your distribution, you can type sudo apt get dist upgrade. It's a little bit more aggressive, but I just want to keep it simple there. So let me go on to the next one. So what I'm going to have you do is I want to show you how to install tools, right? So we saw I did an update to my repositories to see if there was any software that needed to be updated. And then if I would have typed upgrade, it would go ahead and upgrade those. But I can also use the apt tool to install new packages or software. So imagine if you go to the Microsoft Store, even on your phone, you go to the Apple Store or you go to the Play Store and you install an app. Well, similarly, we can do this from command line, and I can type, oops, give me a second. I can type sudo apt install git. So git would be the tool here that I want to install. And this is going to allow us to clone GitHub repository. So this is the GitHub tool. And so I'm telling it to install the GitHub tool. And you don't have to do this piece, but this is another trick that I find useful is if you add the -y, what that will do is that it will say yes to the question. And so I'm going to leave the Y off just to show you what that would have prevented. So if I just do sudo apt install get, it's going to come up with a question here. It says, after this operation, 34 megabytes of additional disk space will be used. Do you want to continue? Yes or no? If I don't type anything, I'm just kind of stuck here. So I know that question's coming up, and that's why I normally, when I install a tool, I add the -y, and that way, when the prompt comes up, it'll go ahead and immediately just install it. Rather than prompting for this. So I can type Y, press enter, and now it'll continue. Let's give it a second. But once this is done, we should then be able to do, to download or use tools that we find on GitHub. And so while this is loading, I'm going to open up Firefox and just show you what we're going to download here. Let's hope the networking is set up right here. So if I go to github.com, rootgate, DNS, host, root, this is a small little script I wrote for a ethical hacking course a few years ago for my students, just to show them a demonstration. It's nothing fancy, but essentially here, it just it shows them what a bash script can do, and it gives them the ability to do that. So what would happen is if you want to use this, obviously you could go here and you could download all these files, but the Git tool within the terminal allows you to download all of these files and immediately onto your system. And I find this useful because there's plenty of times I want to go out and look for lists like, let me see, sec lists, Raft. You may want to find a tool like, or even just a list here, like the sec list provide passwords, common passwords. And so if you wanted to download this, by installing that Git tool, you could easily download this. And you could see maybe if you wanted to download, what are some good ones here? Honeypot captures or leaked databases. I think they have here like the Ashley Madison usernames and passwords. This is a list here of all of these. Let's see if I can see the raw view. So this is from the dump on the dark web, and you could get all these different, let me scroll down a lot further. Okay, here's different usernames or passwords that you might want to try against your victims or inside your own environment to make sure that these breached passwords are not being used inside your environment. So checking your own passwords. This is just one example, but if you like this and you want to download this, well, after using or installing the Git tool within Linux, you can go ahead and you can basically just download this using terminal rather than going out there and trying to find these or download all these files one by one. So I think it's useful. Let's see if it's, let me go back to the command prompt here. We see it's done. I'm going to type clear just to clear my screen. So now that it is installed, the Git tool is installed, what I can do is I can use git clone, and then I can type out here the address, and you're going to do this for a lab. So it's github.com r00tgate rootgate /DNS / host -root. And hopefully I spelled this right. We'll find out very quickly. Okay, it downloads some objects. I'm going to look at these, and I see this DNS brute force tool. So if I cd into this DNS, I press the tab, you can see that. So if I type cd DNS tab, it completes that for me. And these are the same tools that when we just opened up the browser, it had this bash script, it had the README file, and it had a TXT file with the different subdomains. So we were easily able to, rather than one by one download these files, I get it, there's only 3 of them, it's not that big of a deal. But what about the one I showed you, like the sec list, where there was tons and tons of password lists that were very large in size? This is a very easy way to clone those GitHub repositories to, I don't want to say steal, but to use other people's work, their scripts, their code, and that way you don't have to start from scratch. You can find a ton of great security tools on GitHub. So this will allow you to do that. So what I am going to go ahead and do is I am going to switch over my screens and go back to the slides. At this point, it's the lab time. So if you have not already, get your VM set up. I want you to do exactly what I did. Log in with the Mike Wiley user, open up the terminal, install the Git package, and then I want you to clone the DNS brute force tool, which is a very small little GitHub repo, and then change directories, cd, into that directory, and then ls the files, just to make sure that you see that there are these 3 different files there, kind of like I had there. Okay, so I'll give you a few minutes.
Yeah, and we're getting a lot of questions about where do we find the virtual machine, and if we're going to get the recording. Yes, all of that will be covered in this link that we've been posting constantly in the chat window. So if you go to that link, it'll take you to our homepage or landing page for this event, which has the virtual machine information, which has the lab manual, slides will be posted there, the recording will be posted there.
And Victor, while they're doing the lab there, is there anything else you wanted to add? I know you're a Linux fan as well, so if there's anything else you want to jump in and say, please. Okay, so the next one is PWD for the present working directory. So as I mentioned inside the terminal session here, I have essentially hidden the defaults, which provide where you're at in the directory and as you move along. And I know I'm kind of stepping ahead of myself in some of the things I've shown you, but PWD by itself here, present working directory, it'll tell you which path you're in. And so it's telling me that I am in /, which is the root, home, the Mike Wiley, and then a folder called DNS host brute. And so now I want to bring this up. Oops. This is the button I want. And I just want to show you here that if I go to file system, this, we can see at the top here, it's kind of small, but there's a /. So this is essentially the same here as this / in my directory path. Then it says that I am in home. So let me find the home directory. There it is. Click on this. And then it says the Mike Wiley. And then it says DNS brute force. So you can see here, this path matches what's here, right? And then I've got these 3 files. So it'll just, PWD tells you where you're at any point in time. I remove that. If you're using Kali Linux or Ubuntu, it'll have that by default. You'll see the path, but the reason I took that out is just so you have the practice there. So when I have this, I don't even know what they call it. This is how bad my Linux administration skills are, but Windows Explorer for Windows, this is the equivalent. I'll call it Linux Explorer just for the heck of it. Inside here, I can see that there are 3 files, right? The DNS, host brute sh, the readme, and the subdomain list file. So if I wanted to see that, right, I can see that I'm already in that same directory, but PWD, I'm here, but I don't see anything. I don't see any files. If I want to display what's in here or list what's inside this directory, like I have it in my, what I've called the Linux Explorer, what I'll need to do is type ls, and that then gives me the same output here. I'll be able to see what's in that directory. So now we see the same 3 files that we had in my Linux Explorer. Okay, one other thing, while we're doing this, when I just type ls, I just get the file names by themselves here. If I want to see hidden content, what I would need to do is type an option A, so ls-a. That then we can see, look, there's actually some more stuff. The .get attributes and the .get, and then there's a .dot and a .dot. These are 2 other things that are here. The other option that I like to use is I like to type ls-l, which displays the contents of a directory along with the permissions. So as we saw in the first example, I just had the 3 files, but I don't know who owns them. I don't know if it's read write. I don't know what these permissions are. So if I type ls-l, I now see the 3 file names, but I also get who the owner is, the Mike Wiley. I see the group that owns the file, which is the Mike Wiley. There's also a group and a user called the Mike Wiley. I see the file size. I see the date and timestamps, etc., file name. And then on the far left here, I also get to see the file permissions. And what we're going to have, and there's a slide for this, but it's broken down in that this first one we'll talk about a little bit later of what this dash is. But if we can start here in these first three, I see an R, W, and then a dash. These first three, whatever values are in these first three areas or placeholders, that tells me for the user what permissions they have. And then the second part here for the next three, the R dash dash, this tells me the group permissions. And then after that, I see R dash dash, which is everyone else or other, right? And so this gives me the collective permissions here on what's going on with this file. And then if it is a directory, you'll see a D here in this first placeholder, but otherwise you'll probably just see a dash there. There's a couple other cases for that. So a lot of times when I'm looking, depending on how you want to see things, I like to see the permissions. So if I'm going to do ls, I like to do ls-l. There's a couple other things if you want to see all with hidden. You can add multiple options like la, and now we can see hidden files and we can see their permissions and so on. And you can see here how the D is now in a placeholder of that dash in that first placeholder. And that's telling us that this is a directory. So this .git is actually a directory rather than a file there. Now I want to show you how I can move in and out of directories. So just like in our quote unquote Linux Explorer, how I can adjust, I can go to my desktop, I can go to documents, I can go to home, I can kind of navigate around in this stuff. There's no clicky inside the Linux terminal. So what we have here, if I clear the screens, is that again, present working directory, I'm inside home, the Mike Wiley DNS root directories. If I want to go back to, let's say, home, the Mike Wiley, I can do that a couple of ways. I can do CD and I can type the absolute path, which means from the beginning, from root, home, the Mike Wiley, and I can press enter, and now I'm in that path. The other option I have is I'm going to go back into that directory. And so we're back where we started. I'm in the DNS brute force. I can also do CD as a shorthand ... and that's going to take me up to the parent directory, which in this case is going to be the Mike Wiley. So if I type that, present working directory, I now see that I moved there as well. So a couple different ways that you can get there. If I am, for example, in the root here, now if I want to go back to where we started here in the home, the Mike Wiley DNS, a couple ways of doing this. I can either do CD home and then press enter. Now my present working directory is home, and then I can do CD, the Mike Wiley, enter. And then I can say, where am I now? Okay, now I need to go into CD DNS. I can do that many times like that. The other option is I'm going to go back down to the root. Oops, sorry. My present working directory is the root. If I want to go there, I can type it as one full absolute path. So I can do CD home, the Mike Wiley, DNS, right, as one long path. And you see how I kept doing tab complete because I wanted it to get there. I didn't want to have a mistype or dashes or uppercase. Pressing enter there, now I'm in that directory, right? So a couple different ways to kind of move around the file structure. Okay, and someone commented on this earlier. I'm going to go ahead and show you how to change users. So obviously you see in the command prompt there, I'm the Mike Wiley as the user. If I type who am I, that also tells me who I am, and it tells me that I am the Mike Wiley. If I want to change to a different user, kind of like on Windows here, or in Linux, if you go down here and you type or click on, is this it? One of these are going to be like switch user. That's lock screen, log out, and then I could log in as a different user. On the command or the terminal here, I can also switch users without logging out fully. So the way to do that is I can type SU and then the username. So for example, user1. Okay, so let's try that again. User123. Okay, and now we can see this is what the prompt default looks like, where we've got the username, the workstation name, followed by the path. And you can see why I got rid of that also, because I only have a little bit of room to type here. But now if I type who am I to verify, I am user1 now. So just by typing SU, the actual desktop here and everything else, this is the Mike Wiley user. But in my terminal prompt here, I've got this open and I am now logged in, at least in the command prompt, as user1. Similarly, I could type su and user1_admin to go into our other user and so on. So we can just switch between users there. One other thing, if I type exit to go back to the Mike Wiley user, if I want to switch over to root, someone brought this up earlier, I can type su, I probably need a sudo before that. So sudo su dash. Okay, and now we see, obviously in the prompt, but if I type who am I am the root user as well. And we can see that before, see how I had a $sign, and now I've got this £sign. It's obviously up to you how you have this prompt. You can modify this file or the bash RC file to dictate this, but the general consensus is that a $sign is a non-root user, and then running it as pound is privileged to root user there. Okay, I'm gonna type exit to go back to the Mike Wiley user, verify that I'm the right user. All is good again. Okay, now I'm going to show you how I can make a directory. So just like here in our quote unquote Linux Explorer, if I want to create a directory, I can hopefully right click and there create a new folder and call it dir02. And now I've got this folder there. Similarly in Linux here, I'm going to change directories to home, the Mike Wiley, so I'm in the same directory. I'm going to clear my screen to make it a little better. If I do an ls, I can see that that new directory we created is there. If I want to create directory 1 now, I can type mkdir, it's for make directory, and then I'll call it directory 01. And then we can see as soon as I did that, it was already an adjustment here. And in our Linux Explorer, if you will, here's our new directory that we created. And there's obviously nothing in it. Okay, if I want to remove a directory, like let's say directory 02, we can see it's sitting right there. I can type out rm for remove directory and then dir02. Okay, and then ls again, and we can see that now we just have directory 1. Directory 2 is gone. Okay, if we want to look at the disk information and see how much hard drive space do we have? Are we full? You know, typically in a Windows system, you can go to this computer or my computer, whatever they keep changing it to, and you can see your C drive, your D drive, et cetera, and take a look at that. So the tool we can use is df, and it'll tell us the different volumes and the amount of space there, percentage and whatnot. I find this personally, I'm a nerd, but not an uber nerd. I don't like converting this into some human readable form. So a little trick that I use here is I type df-h, and this then puts it in megabytes or gigabytes. So I can see that this volume here, dev SD1, this would be kind of like your C drive in a Windows machine. And it's the root directory. That's how it's mounted. So this is what we've been working on. You've seen me CD into this root directory. It's 11 gigs in size, and we have 6.4 gigs used, and we have 3.4 or 3.9 gigs available, right? So this is almost like looking at my computer or this computer within a Windows environment. Okay, let's take a look at the tool uname. So I'm going to clear my screen again. And I'm going to use the new uname. By itself, it's just going to give me some basic information like the name, or that we're using Linux, which isn't that useful. But if I use uname, I spell it correctly, -a, it provides a lot more information here. I can see that we've got it's running Linux, obviously, but it has the workstation name, followed by it's apparently underlying Ubuntu. It tells me sometimes the build number. It's probably 1804 right here. So we get more information about the underlying system, whether it's x86 or 64, et cetera. So I just bring this up because it kind of gives you a little better information about what system or operating system you're using. And this is a common command that pen testers and bad people will use when they get on a system. They'll do who am I to see where did I get a shell. You know, they spread out lots of malware and different campaigns. They don't know who they compromised, so they'll type who am I, uname a, and host name to see, you know, basically what system they're on, what operating system, who they are, what permissions they have. So these are kind of enumeration commands that you may see in your logs or during a pen test. Okay, next command is ps. So I'm going to clear my screen here. PS will essentially give us the different processes. Typing PS by itself isn't terribly useful. It'll tell us the process ID, TTY, some time, and then basic information about the process. Now, what you'll probably see if you want to look a little more like Task Manager within Windows and see a lot more detail like you would in a Windows environment, you're going to want to type out PS space AUX. The A stands for show processes for all users rather than just this session. U displays the process user and owner, and the X will also show processes not attached to the terminal. So this terminal, there's nothing really running. We ran PS, so that's why we see this, and we running bash, which is the terminal. So there's only 2 processes. So adding that X shows us things that are not just inside this terminal. U will display who owns that process, and then the A will show us for all users, not just the Mike Wiley. So if I type this out, we can see it's a whole lot more information, and we can see that you got the root, the Mike Wiley, other users here. And then let me see if I can make this a little bit bigger. Let me clear my screen, run this one more time, see if that helps out. Okay, and then we can also see more information about the process, where it's coming from, a lot of information here. So this is essentially like the task manager within Windows. You get all of this. I do want to show you something here while we're at it, just as I mentioned I would, and we'll come back to many more examples of this, but let me see if I can find something somewhat interesting. I'm going to guess on this and hope this comes out well. So rather than seeing this whole list that's output here, if I wanted to take the output, right? I typed PS AUX, and the standard output, I got this, everything on my screen. Now, what I can do is I can redirect this to a file, right? We're going to redirect this to ps.txt. And when I do this, as soon as I press enter, see how I didn't get everything on the standard output, which was my screen? Instead, I redirected that to a text file. Now, if I just use the tool head, and I'll get more information about what head is later, but I just want to look at this text file, and we can see that's the same information. We got that, but now it's stored in a text file rather than scroll up on my screen here. Okay. One other thing that I can do is that if we do PU or PS AUX, and I want to then take the output, and I want to take the output of this tool and put it as the input of another tool, I can use that pipe that we talked about in the beginning of the slides. So now all that information you saw on my screen or in the ps.txt file, all that information is now getting sucked into the next tool, which we'll talk about grep later, but I'm going to do something like, let's see if there's any processes running that have the name Python or match Python. So essentially I'm listing processes, taking the answer, which is all processes, putting that into the grep tool, which grep will then act almost like Control F or find within a Windows environment, and it lets me then search for things like Python. So you can see there, out of all those processes, there happen to be 3 different processes here, this one, and this one, that matched somewhere within the line, it matched Python. So Python 3, Python by itself here. So there's 3 different lines that match that. I could obviously then keep going, so I can chain these together, and then I could say, I could use another tool like cut, and you could just keep chaining and chaining and chaining, and the use cases for this will be more apparent a little bit later, but I just want to show you what that chaining kind of looks like. Okay, so now that we've looked at this, and we've got some processes here, I don't really want to kill Python. Well, I can, I guess. The other thing I could do is, now that I've got a list, and these are the process IDs here, I can take these process IDs and I can actually kill them, kind of like in Task Manager where you end the process. And so I don't think I want to actually kill it, but what I could do is I could type kill, and then the process ID, which in this case, if this is the process I wanted to terminate, I would type 772, and then this process here would be terminated, or the process would end if you were in Windows environment. So that's a way to terminate, kill, end a process. Okay, now services. So services, just like in a Windows environment, you may want things to start up when Linux starts up. For example, if you install Apache 2, so you want to have a web server, and you want the web server to basically display the website every time the server starts up, right? You wouldn't want your web server, when it starts back up, you have to manually turn your website back on. You want it to start up every time. You can essentially tell the service to start at boot. Or you can even start the service, stop the service, restart the service. And so one of those things, for example, if we were using Apache, I don't think it's installed, but I would do service or sudo service Apache 2, whatever service we're talking about, start, and this would then start that service. If I wanted to stop it, I would just put stop at the end. If I want to kind of bounce that service and have it stop and then restart, I could just type restart. Okay. Now let's talk about touch, right? So what touch does, it creates an empty file and or it will change the timestamp of a file. So if I do an LSL, again, and we look at all the files here, I see that ps.txt. And if we look at the timestamp here, I've got June 26, 1522. So 1522. Now, if I use touch against that file, because there's already content there, if I just touch that and then we do ls-l again, it's now 1526. So I basically just touched the file and it's updated the timestamp with that. So looking back here, comparing the two, 1522, and then when I just touched it, I didn't edit it, modify it, I just touched the timestamp. It's now 1526. The more useful use case for this tool touch is sometimes you want to create a text file just to test something and you don't want to have to open a text editor and then put junk in it or just have it there and then save it and finish that. What you can do is I could say touch example01.txt. And now I see that text file is here, right? And it's blank. If I try and look at it, I use the cat tool, which we'll talk about later. There's nothing inside of it. It's just a blank document, okay? If I want to add something into that file, I'm going to show you another way of redirecting and appending stuff. If I want to say, hello workshop, I actually need to put echo. I'm going to echo this, just hello workshop. And typically if I just enter this, if I could spell it correctly, echo hello workshop, it just displays that on standard output. So what I can do is I can redirect hello workshop into a file, example02.txt. And now we should see, if we cat out this file, we should see txt, hello workshop. Okay. Now, if I go back here and I say, let's just put something else in here like line 2, what's going to happen is if I use the single caret here and I put this into example 2, it's going to overwrite the file. It's just going to dump that into that text file. So now if I cat out example 2, we only see line 2. We've essentially erased hello workshop that was in that text file. If I want to append to the file rather than erasing everything, what I can do here is I can add line 3 and put an extra caret there. So this will now append it to it. And I'll even put line 4 just to illustrate this, and so on. And so if we look at this text file now, what's going to happen is it's appended line 3, line 4, and so on. So that's the difference in the single caret versus the double caret like we talked about early on in the workshop. Now, I've been using cat a lot, but essentially what cat does is it's not like the meow meow cat. It concatenates or displays the contents of a file. So I've got these different text files here, like example2, ps.txt, example1, these different text files, they're sitting there. And just like if I was in Linux Explorer, if you will, and I want to look what's inside of this, I can obviously open it with the equivalent of Notepad or Word. I can open this up in the program and I can see this. Well, what I can do with cat, if I open this in the, what are they calling this? The text editor program, I can obviously modify this and I can add line 5 and so on. But the cat tool is almost like read only. So if I just cat out example 2, it's essentially just like read only. It's displaying the contents of that, almost like a Adobe Reader. It's like a PDF. If you're looking at that, you see what's inside, but you don't have Acrobat, so you're not editing it. You're just seeing what's inside that file. Super useful, and we'll use cat a lot during this workshop. Additionally, we have head. So what we can do with head is, rather than seeing everything inside that file, for example, if we look at ps.txt, and I display this out, see you have to keep scrolling up and there's a lot of content here. Well, maybe I don't want to see all of this. I only want to look at the top few lines. Well, what I can do is I can type out head, let's do ps.txt, and it only displays the top 10 lines by default. Now, if I only want to display the top, let's say 3 lines by, not by default, but I only want to see the top 3 lines, the thing I can do here is I can type head-n and then put a number like 3. So I want to see the top 3 lines. And that only shows me the top 3 lines of the file. This is useful, especially if you have a giant, let's say 1 million line Excel file, but you just want to see the header, you could easily do this just to look at the top. Another tool we have is tails. So there's similar like head, it's going to show us the bottom 10 lines of the file, right? And just like head, we can also define that and say, well, I don't want the top 10. I just want to see the bottom 1 line or bottom 2 lines or whatever number of lines you want to see. So you can keep typing that out. One other useful piece that I don't have a great demonstration here. Let's see if we can do this. This one's not staged. If we go look at our log directory here within Linux, generally in the var logs, this is where you're going to see like syslog, system log, stuff like that. I see syslog here. So let's see if we can look at this. If I tail syslog, it's in var log syslog. We can see this here. But imagine if you're looking at a log file, especially security logs, and you keep wanting to refresh this and then keep refresh this and keep, it's kind of a lot of work to look at that last line. Something we can do here is I can tail, I'm actually just going to go up here. I can use the -F option, and this is going to essentially just keep watching the file and it'll display if there's any changes. Network. There we go. Enable my network, disable it. See how I didn't even have to reopen the file, the log file. It just automatically shows me the newest entries at the bottom there. Okay. Okay, also I want to show you less. So I've been showing you cat, I showed you head, I showed you tail, but now I want to show you less. The cool thing about less, and if we do less against the PS file that we created here, I can use my up arrows and down arrows on my keyboard here, and it lets me almost page through or scroll through, and I can even press the space bar, which does a whole page down. So you can use the space bar, up arrow, down arrow, etc., and you can kind of get through some of this stuff. The other thing I really like about this is kind of like how if you recall just a few minutes ago, we catted out the contents of this file, and then we piped that into grep and we searched for Python. Well, one other thing I could do here as well, in this, you see kind of the colons in the bottom left corner here of my screen. I can type a / and there's plenty of other shortcuts here and things you can do. But one thing I really like is if I type Python here, I can then go ahead and see it's going to show me, it's almost like grepping through this. It's going to search for those keywords. If I type / again, press enter, it'll show me the next iteration, / enter, and I'm done. All right, so I can kind of search through. It's almost like Control F in a document. Someone asked a question, what's the difference between more and less command? Great question. I used to have more in here, and there's a Linux joke about more is less and less is more, but the main difference here is that if I do more, I can't use my up and down keys. You can't see my hands here because we're not in person with COVID, but if I press the up and down arrow, nothing's happening on my keyboard. I press the space bar and it pages through it. So you could see 14%, 22%, but I can't even go back up. And someone may correct me and say, well, there's some shortcuts for that and other things, but from what I've seen, it's got a lot less functionality here. Whereas if I used less, I have that ability. I'm pressing down arrow. Now I'm pressing the up arrow. Now I'm pressing space bar, up arrow. I can really go around pressing the / and then I can look for those keywords like root, and it shows me all the findings. So it's got a little bit more functionality to it. Great question. Okay, let me look at the next tool. Whoops. Nano. Okay, so far we've just been looking at these text files, but what if I want to edit something? So we've got that example2 file that we've been looking at. And just as a reminder, I'll pull this up so we can see that. And we've got those different lines. Well, we're missing line 1, right? I've got line 2, line 3, line 4, line 5. I now need to edit this. So what I can do here is I can type nano, and there's going to be people who start fighting in the chat, but nano lets me, almost like text editor or notepad within Windows, this allows me to now go in here and modify things. So now I can add line 1, and I can kind of use my arrow keys. I don't have my mouse, but I do have the ability to go around here and start editing stuff. And when I'm done, I can press Control X to save. And it'll tell me, do you want to save this file? I press the Y button, and then it says, well, what's the file name? It's already defaulted to example2 since I edited example2, and I'll press enter there. And now if we cat example2, I can now see that's changed. So Nano is essentially a text editor, kind of like Notepad. Okay. Now, for those of you who have already started fighting in the chat.
What about VI or Vim? Come on.
Yep. So absolutely. And old school, old timers will fight, and there's constant debates. I encourage you to go look at memes. There's tons of them about Nano versus VI or Vim. I happen to just like Nano better. I know VI and Vim's got more functionality. You could do more with it. It's to me more complicated, and I can never remember exactly what I want to do, and so it takes more time to look it up. It's one of those things I probably should just spend more time in, but if you're newer to this, it may take you some time. If you've got the time, go ahead and use VI and Vim. You'll find it on more systems, so I encourage you to use it. But if you are already, I don't want to say discouraged, but you already think that there's too much we're talking about, maybe stick to Nano in the beginning, and then you can transition over. And I'll just kind of show you here, and hopefully I don't get stuck in VI forever. If I VI into example 2 here, we can see this here. Now, this is the part that confuses a lot of people. So I see I'm at the end here of line 5. I press the enter key. Nothing happened. I press enter again. Nothing happened again. Hopefully you can hear my keyboard. I can't edit. So now I press the J key. Well, actually it went up instead of J. Or maybe that's the K. I'm pressing K and it's going up. I'm pressing J, it's going down. What in the world is going on? I'm trying to type J, K, those kind of things on my screen. It's just not working. Okay, so now I just frantically hit my keyboard and all of a sudden I start typing in. Well, that's because I think I accidentally typed the I key, which is for inserting text. So the text editor doesn't allow you just to start typing. You have to insert stuff. So now I start doing this. I press the back, not the delete key, but the backspace on my keyboard to get rid of this junk I just did, but it's going back like an arrow key. Look at that. I can't, now I press the forward key and now I'm entering C's. So now I press the down key, I've got B's, A's. I can't do what I want to do here. So now I've got junk in here and I didn't edit it properly. This is why I encourage people, if they're new and there's a lot of things they're learning already, stick with Nano, because there's a lot of little finicky things and you have to know what keys to press to actually start editing things in.
One thing I was going to add is just keep in mind, if you downloaded and installed a vanilla Ubuntu or Linux, Nano might not be installed out of the box. So that's something you may have to install it before you can start invoking that program.
Yep. Yeah. And that's, VI is almost everywhere. But most of the time, Nano, for the most part, it's there, but other times it's not. And especially if you're offensive security or getting into pen testing, you don't know what system you're on and you don't know what tools are there. So you're going to have to use whatever's there in that system after you compromise it. So if you want to save changes, that's the other thing. You can't just press like Control X and save or whatever it is. You have to press the escape key to get out of that. And then you press colon, and then there's different little secret commands that you have to go Google. But essentially, if you want to save it, you press WQ exclamation point, not even like save exclamation point or get me out of here or help or anything like that to exit out. You have to type WQ exclamation point, and there's different variances for what you're trying to do. But finally, I've escaped out of this thing. So that's, I kind of exaggerated there of how crazy it is. If you've got a cheat sheet, I encourage you to use it, but it is not as user-friendly as some of the other tools out there. Okay. Now that I've scared everyone away from ever using VI or Vim. Going back to some of the permissions here, let me do an LSL just so we can see those permissions again. And so I want to go back to what these are here, right? If we broke it up by these first 3 placeholders, then the next 3, and then the 3 after that, and so on. So what these mean, and I'm actually going to switch back to my slides now that we know what I'm talking about. Okay. And I think that this slide kind of helps you out. It helped me out when I was first learning it, and it shows you that those first 3 placeholders, ignore that first dash there, but that is the read, write, or execute permissions for the owner. And the next 3 are going to be for the group permissions, and then after that, it's going to be everyone else. So what those R, W, or X's mean is that if you see an R, it means that owner or the group or the other users have read permissions, so they can see or open the document. If you see a W, it means that they can write or edit it. And if it's an X, it means they can execute it, which means if it's a script, like let's say a bash script, they can actually run that script. Okay. And so you might see in this case, obviously we're looking on the screen that or my VM that we had, and obviously on the screen here that you're looking at in the slides, you've got there R, W, and X's, and then dashes if it's turned off. But there is a shorthand rather than typing out the R, W, or X. A lot of times you'll actually see it referenced as a number for all of those. So the way they do that is that if you see an R that's turned on and not a dash, so it's an R, that counts as, I'll call it 4 points. If it's writable, it counts for 2 points. And if it's an executable, or that group or user or other is allowed to execute it, it's a 1. So if, for example, they're in that blue section in the first column, or, not talking about that directory bit, but the blue section there, if the owner can read, write, and execute, that's 4 plus 2, which is 6, plus 1, which is 7. So the permissions for the owner are going to be 7. Now, if we, on the next column over, let's say we give the group read permissions, but they're not allowed to write, so it's a dash, but they are allowed to execute the script. That means that we add up 4 plus 1, which equals 5. So the permissions for the group is going to be 5. Now, for everyone else, if we just want them to have read permissions but not write or execute the script, it's going to be just R, which is 4 plus 0 plus 0, or just 4, right? And so the way you write that out is when you're changing permissions, you can write that shorthand, and we could essentially say, change the permissions to 754. And that's going to mean that the owner can read, write, and execute. The group is read and execute, and then everyone else can just read that file. So a couple different ways you might see that. You might see the R, W, and X's, or you might see those numbers, which essentially you just have to kind of think back. Oh yeah, read is 4, write is 2, and execute is 1, or come back to this chart, which is really helpful. Okay, and so one thing I want to mention about these permissions is that most distributions set the default home folder to 755. And what that means, if we go back to our slide here, is that 7 means that the owner can read, write, and execute to it. And then the group and everyone else can read and execute. So what I'm trying to tell you is that if you have a system administrator, or Linux administrator, or a security administrator, or analyst, or engineer, whoever they are, and they have higher level permissions, and they wrote a script, and it's possibly got some interesting things in there like backup or create new user or whatever you can imagine, we're essentially saying that other users and users who didn't create that script, by default, things in the home directory, they may be able to execute that. Okay, and then some users, or the admin or developers, or other stuff. A lot of times you find scripts and all kinds of crazy things in their directories, and we'll kind of look for that in one of the labs here. The other reason I bring this up is that early in my career, when I started using Linux, I didn't understand these permissions, and I think it's an important part, even though it's a little bit confusing, because you may get yourself into a lot of trouble. If you're looking there on the upper part of my slide, you can see that the file name for everyone directory is owned by Sammy, and the group is Sammy. However, everyone can read, write, and execute. And if you make the mistake of allowing everyone else, or a user that's not a trusted user, to write and execute to your backup scripts or your backup jobs or your scripts to create new users or whatever it is, you may accidentally be doing things that, or making the permissions overly verbose, thinking it's in your desktop, and yet other people can access that. I will tell you a story real quick here. My early days of Linux administration, I made the mistake when I had problems with the web server. If I had issues running a script or a file and I didn't understand all of this, I would change the permissions of the file to 777, which means anyone can read, write, or execute. The owners, the groups, and everyone else can read, write, and execute to those files on my web server. Big no-no. So I made those mistakes. I'm hoping you don't. Now we're on to a lab. So this lab, I'll read you what the instructions are. I'll give you a quick demo and give you a few minutes to do that. So you're going to log in with the same user, the Mike Wiley. You're going to open up a terminal. You're going to switch users to user 1. You're then going to view the home directory. So remember, user 1 is the lowest permissions that I was able to give a user on Mint. Obviously, you can customize things a little further, but through the GUI, I created a low-level user. And you're going to then look at the permissions of the home directory. And then you're going to look in the home directory, and you're going to see if there's any files with the permissions for the user 1 admin, so a privileged user. You're going to look in there and see if there's anything containing passwords that you might be able to see for the administrator. So I'm actually not going to demo that. I think it's somewhat self-explanatory with what we've been doing, but your goal there is to look for what the user one admin's LinkedIn password is. Once you have that, go ahead and post that in the chat.
And once again, I'll repeat myself. All of the slides recordings will be posted on the LinkedIn event page. So if you don't have it bookmarked yet, I will go ahead and put that into chat one more time.
And fun fact, if you do find the user one admin's LinkedIn password, it is Victor's LinkedIn password.
Oh man, you're gonna give it away like that?
Time to go change it.
And for those who are learning Linux, please subscribe to our Zeek learning series as well, where we show how to install Zeek and look at the logs and look at anomalies. So all of these Linux Ninja skills you're learning here are going to be very useful.
All right. So the next thing we looked at here, and maybe I'll do a little bit of the demo here, but if we look at the permissions here of what's going on in this directory, I've got these text files, and we saw that I created like example1, example2 with read write, read write for the owner, read for the group, and read for everyone else. If I want to adjust that, this is where we were talking about that last slide where there's examples of the numbers. What I can do is if I want it to be, let me see, let's do read, write, execute for the owner, read, execute for the group, and then read for everyone else for example 2. So what I would do is I would do sudo chmod. So I'm modifying the permissions. And then I put the number here. So you can do it a couple of different ways, but the shorthand is the number. So read, write, execute, that's 4 plus 2 plus 1, which is 7. If I want the group to be read and execute, that's 4 plus 1, which is 5. And then if I want everyone else just to be able to read, which is 4, I'm just going to add that. So chmod 754, and then what I want, which file I want to change the permissions on. So example2.txt. If I enter that in, it'll want the password. I'll enter that. Now, if I do an ls-l, we can see that the permissions have changed here for that example 2 to read, write, execute, and then read. Okay. The other way we could do this, let's say, for example, 1, if I just want to add execute to everyone. So I want to have it read, write, execute, read, execute, read, execute. I just want to make it a script that anyone can run. What I can do is a chmod or sudo chmod. Instead of doing the actual number, if I just want to add execute to everyone's permissions, and then the file, which is example 1. Now we can see that all users can now execute that. So a couple of different ways that we could go ahead and do that. Okay, so I showed you how to change the permissions there, but we still see that the user that owns the file and the group that owns that file is the Mike Wiley. So if I want to go ahead and change the ownership of that so someone else owns that file, what I can do here is, lost my mouse, there it is. What I can do, I'm going to clear the screen. If I want to change example 1 and make the owner root instead, I'm going to go ahead first and, oops, just do this. We can see again, the Mike Wiley is the user and group that owns it. If I go ahead and type sudo chown, so I'm changing the ownership, I then type the user and then the group and a colon between the two. So if I want the root user and the root group there, I would type root:root and then example1.txt. And now if we do ls-l, we can see that that has changed. The owner is now root and the group is now root as well. Okay, and someone asked, does the use need to be or have both R and X read and execute in order to execute the file? I've tried giving it chmod 111 on a file and I'm not able to execute. Well, depending, if it's a bash file, you probably need to be able to read it as well. So you probably need read and execute for that. If it was just something like an actual binary, I'm guessing you probably just need execute, but I haven't played with that as much. Okay, we've already talked about echo. I'm gonna move over that. I'm gonna now show you about copy. So for copy, what I'm gonna do is I can copy a file, maybe move it to a different directory, but essentially it's like right-clicking on a file, copying it, and then pasting it in another location. So for example here, let's take example 2 text file, and we're gonna make example 2 copy.txt file. So I would type cp example1 or example2, sorry, .txt, and then that's the source. And then I would give a destination, which is example2-copy or whatever you want to call it, .txt. So this first one is where's the source? What am I copying and where am I pasting it to, essentially, which would be this file name. Press enter, and we can see now I've got copy2. It inherited the owner, the group, and the permissions. Almost, it actually looks like it did not copy over the execute permissions, which is interesting. Okay. Now, if you want to move something, there's two use cases for move. So if I want to take the example2-copy, I can obviously move it to a different location. For example, our directory 1. So if I want to take this file, the example2-copy, and I want to move it into directory 1, what I would do is I would type mv for move, example2 copy. So this is the source. And now where do you want to move it to? So I can move it to dir in this directory and then call it example. Let's just call it example2.txt, right? You can rename it, or if we want to keep it exactly the same, example02 copy, just to keep things simple. And now we can see that that file has now been moved. So we no longer have that copy version of it sitting there. But if we go and look at the dir directory, we're going to see it located there. Okay. Now, the other use for this, so it's kind of like more of copy or a cut and paste rather than a copy and paste. So CP is kind of copy and paste, if you will. And MV for move is more like cut and paste. The other cool thing you could do, there's no rename within Linux that I am aware of, at least. So the thing that we can do here is we can rename a file using MV, because it's kind of like cut and paste. So I can use MV, and inside dir1 we have the example text file, and if we want to rename it, we just do the same syntax here. So it's still going to be inside directory 1, but we're now going to call it example03.txt. Okay. And now if we look inside there, we see that that file has been renamed. So MV can be used to move things, or it can be used to rename things. Okay. I'm going to skip over what links do. Essentially, it creates a shortcut. You can look at the slides a little later about that. Same thing with DD. DD is a tool that allows you to copy and convert files from one type to another. It also can be used for bit-by-bit copying for forensic imaging of a Linux system. But I want to get a little further ahead here for some more labs. So the next demonstration I want to show you is the history command, right? We've kind of used the up arrow here to scroll through the last commands that I've typed, but we're now on hour 2 of this workshop, and I would have to keep scrolling up to get, really far back on wherever I want to get to a command I started at with 2 hours ago. So one other thing that we can do is that we can actually just type out history, and it'll give us all the commands and within the order. So we see these are starting at 170 commands that I've typed today. History is the most recent, and it's line 170. If we kind of scroll up, we can look through all the different commands that I've used. There's obviously a limit to this, and which is why I suggested you script when you start. So you're recording all the input and the output. But this is just showing us a history of all the commands we've typed out throughout this workshop. Now, if I want to clear this history, because obviously if you could imagine, if I type something like sudo blah, 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 and then I didn't pay attention and I said password 123, and I was like, oh shoot, I messed that up. Well, my password is now sitting in history, right? Same thing with file paths, these directories, the file names we've been working on, all this stuff, permissions that we've changed, possibly insecure permissions that we've added, all this is now recorded here, and anyone who has access to my terminal can see that. So what I can do here is I can type history-c, which is going to go ahead and clear that history. Now I have nothing left in there. So pros and cons with that too. This is something I would absolutely alert on in my sim. If someone's clearing their history, I want to know why. Okay, now let's look at wget. I'm going to clear my screen. Okay, and someone else mentioned as well that a quick trick is to type the exclamation point followed by a number like 165, and you'll be able to run that command again. Absolutely. Oops. if we look at this and we see these numbers, this is what the person's referring to. And so what you can do is you can type exclamation point 5, and this is going to rerun the history. So see the 5 represents here. If I enter this, it basically runs history again. So it's a little shortcut if you want to rerun something in your history. Thank you for sharing that. Okay, so wget. This is pretty cool to essentially download files from the internet. It could be a single file like an Excel file or a text file, but it could also be used to mirror a website. So for example, what I can do is if there's a website I want to grab a file from, is my browser still open here? Let's see this Ashley Madison text file here that we were looking at on the sec list. I should be able to, I didn't test this, so hopefully it works. I should be able to type wget, paste in this web address, and it should download that, hopefully. Yep, there's my Ashley Madison file. So if I do the head and look at Ashley Madison, we could see it's downloaded this. So it's not the actual text file because I wasn't looking at the raw view, but it's actually, let me go down. This is the HTML or the actual web page. So I'm downloading that web page there. The other cool thing you could do about this, if you want to mirror a website, you actually want to copy over a website or clone a website, you can use the -M switch with wget, right? So it allows you to download files from the web. I'm going to skip over traceroute. The other thing I do want to show you here is curl. So if I want to look at a website without actually visiting it in my browser, so this is a fake website I have for one of my college classes that I teach, is blueteamacademy.com. Did I spell that right? Okay, and so this is like a fake website with fake users. Obviously, I went here, but if this is a website that I was not familiar with and I did not want to visit this, let's say it's possibly a malicious site or malware, and I don't want my browser to render all this code, the HTML and so on. If I want to go ahead and actually just see this the raw source code inside of Linux without rendering that, what I can do here is curl blueteamacademy.com. And curl stands for CURL. And this will then go ahead and display. Let me actually do this again, but I'm going to pipe this to less just so we can control the output. And so I can see here I've got, let me look. It's all the header information, themes. Let me go down further, menu. Oops, here we go. So here's the same website. Blue Team Academy is a stage site to teach students about blue team and red team operations. Well, that's the same exact thing that we have here, right? But my browser just made this pretty by rendering all the source code, but I'm able to see everything, including the scripts that are being run. So if I don't trust the site, going back up to the top here, or actually let's see if I can search for a script. Look, we can see all these scripts that are embedded in the page and then start digging into it a little better. Whereas if I just open it up in a browser, even in Linux, I don't see any of those scripts being run. It's all being rendered by my browser, right? So I do that all the time. We get phishing emails, we get clients with things. I immediately just curl it. I have gotten in trouble once because apparently Carbon Black picks up that telemetry from Windows subsystem for Linux, and it reported it and actually triggered that my Windows system was running curl from a bash shell, and it went to a malicious website, which I thought was pretty cool that it actually picked that up. It was impressive. So we did get an alert off of that, but for the most part, I mean, it's not rendering any of the evil that's possibly running in the background. We're getting the plain text view of the website. Okay, I'm gonna switch back over here to show you regex, and then we'll spend a little bit of time back in my slides before we move. Before we move over to the lab again. Oops. Okay, so regex is short for regular expression, and it's essentially a sequence of characters that defines a search pattern. So it allows you to imagine if you're on a web page and you press Control F on your Windows machine and you search for some keyword. Well, the challenge though is that with Control F and you're searching, sometimes it's case sensitive, sometimes it's not, depending on the setting you use. And even if it's not case sensitive, you can't look for wildcards or things that are possibly look like an IP address or a URL. You know, you get a little bit, you're a little bit limited there. And so regex lets us search for things, but in a little more advanced way. There's a question as far as, but if the fish URL had an ID in it, it does tell the bad guy that an email legit is legit and active. Yeah. So, I mean, there's obviously pros and cons to going to websites, and you're going to have that discussion inside your organization. But if we get an email or a URL that someone's supposed to click on and I'm trying to validate it, I rather look at it through the terminal rather than a browser or anything else. And that way, I've got a view of it. Otherwise, I'm not sure how else you're going to see if it's evil or good or what it is. So yes, they could have tracking. They could, see that you've opened it and stuff like that. But that's just, obviously depends on the situation. If you are a government entity and you think it's an APT, you might think twice about that. Most organizations, though, it's probably safer than any other way that you might try and detonate a link. So back to regex. So it allows us to have search patterns. You can look, as I mentioned, for IP addresses, any IP address or any IP address that's private, or you can just, your imagination go wild for different ways that you can do things. Next slide. Here's just an example of regex. It's a whole topic in itself, but essentially here I'm using a regex tool. And in the bottom there, the testing strings, I typed out a bunch of things relating to password, like pass lowercase, pass uppercase, password lowercase, password uppercase, passphrase lowercase, passphrase uppercase, the password lowercase, the password uppercase, password 123 lowercase, password 123 uppercase. I mean, you can think of all these different permutations of password, passphrase, etc. And so if I use regular expression, I just search the string, kind of like if we were in Firefox or Windows and I just did a Control F to find something. If I just search for pass, you can see there that the second pass, which has an uppercase P, it does not exactly match because it's an uppercase P. Now, if I wanted to tell it that essentially I wanted to get a little more advanced instead of just pass, and I wanted to look for other things like you have to start with pass. So the password doesn't get triggered. And you can see in the bottom there where it's kind of highlighted blue, that means it's a match. So if I use regex of a uppercase caret, or I'm sorry, an up caret or an up arrow there at the beginning, that's essentially saying search for things that start with pass. So even though I have the pass and pass is lowercase, or the password it's lowercase, that doesn't match because I'm looking for only matches where it starts with pass. And that's why you can see that pass, password, passphrase, and password 123 are the only 4 matches. And on the far right, we can see that I've typed /d/d/d/d, which is essentially any digit or numeric digit, any numeric digit, any numeric digit. So the /d is a numeric digit. And so of my test strings in the bottom there, pass, password, all those other phrases, those didn't match, but password 123 and lowercase or uppercase, either one, those match because it found those three characters back to back. So very basic examples of regex, but I just want to give you a couple demonstrations of on the far left there, we have a literal string. The middle, we have that string, but then we're basically saying it has to start at the beginning. And then on the right, we're using some regex expressions there that you're probably not familiar with. So we can use regex with many other tools like find, grep. We're going to get into some more advanced stuff here. So the find tool is pretty cool. It allows us to search for files with detailed granularity. For example, you can search for files that were accessed within the last 5 minutes. You can search for files that were that have insecure permissions like 777. You can search for all executable files on your file system, right? It's a very granular way of searching your file system. You could search for file extensions like .sql files. You can search for any files that contain user or pass as part of the file name. I mean, you could just anything you want to find in your file system. You get very granular, far more granular than you can in the Windows Search or Windows Explorer. Okay, so now we're to a lab. What I want you to do is log into the virtual machine with username the Mike Wiley and password of Linux. Open terminal. We're going to use the find command to identify any overly permissive files on the file system. So we're going to, instead of just find and then going in the root file system with just a /, there are a lot of things in the system that you'll find that have 777, but I wanted you to find just overly verbose permissions on files within the user's home directory. So you're going to tell it, you're going to basically say, go find a file type with a permission of 777 in any of the user's home directories. And then I want you to let me know what files did you find, And then I want you to go ahead and use the find command to identify any files in user one's home directory that contain the word pass. Okay, so then I give you the commands there, and just let me know which file name you found and where it's located that has possibly a password file. Now, we're going to talk about the file command. We go right back into another lab here. So on my screen, basically the file tool determines a file type. It does a bunch of different tests against a file to help determine what type of file it is. Inside Windows, what happens is that when it sees a file, it uses the extension. So for example, resume.doc. That .doc then goes into essentially the registry, and it defines what program should open that, basically because it's a doc type. That's why you can easily just change the extension. Then Windows will tell you, are you sure you want to do that? You might cause some problems. And if you change the extension type, then all of a sudden Word, now it opens up in something else and you get a bunch of funky characters. So Windows is dumb, and it just looks at the extension type to determine what type of file it is and what program should open that file. Linux, on the other hand, doesn't need that. You don't even need a file extension. I've been purposefully calling our example text files .txt just so I don't confuse people, but I don't even need that. I can just call it example2, and Linux will look at that and say, got it, I know this is a text file. We don't need to use extensions. That's a Windows thing. So the file tool, and it gets a little confusing when I say this, if you run file against a file, it will run those different tests to determine what type of file it is. So I'm going to show you, I'm actually going to have you do this, and then I'm going to show you an example, and I'm going to lead that into another lab. So what you're going to do is you're going to go back to your lab environment, log in with the Mike Wiley, open terminal. You're going to go into the directory home, the Mike Wiley, lab files. Remember, it's case sensitive. Lab files, case sensitive. And then you are going to look, I've placed 4 different files there for you, and I've called it file 1, file 2, file 3, file 4. And I want you to run the file tool against those. So you're going to type file space file 1, and then you're going to determine what type of file that is. You're then going to run file 2 or file against file 2, and so on and so forth. And you're going to keep determining what type of files those are. And so real quick, I'm going to switch over to Linux, my lab environment. I'll give you a demonstration, not showing you exactly those, but I do want to show you how this works. And then you're going to try that in your lab environment. Okay, so if we look at where we're at here, I see that there's our example or a ps.txt. I'm going to say mvps.txt, and I'm going to change that to ps without an extension type. Right. So now if we do an ls, we can see that PS is no extension type there. However, Linux, like I mentioned, we'll take a look at that, and it knows what to open. It knows how to read that. So if I run file against PS here, it tells us that it is an ASCII text file with very long lines. If I run this against a binary or something else, it'll just like this. It'll say it's a zip file or whatever else. So even if I do, let's see if I can just quickly do this. PS, and we'll call it ps.zip. Oh, I don't even have it installed, huh? Okay, well, never mind. But if you run this against your other files that I gave you, file 1, 2, 3, 4, you'll have different results than just ASCII. And I want you to identify those, put it in the chat of which file was which file type. And I'll give you a couple minutes, and then I'm going to show you something else that's kind of cool. It's a little later lab, but I do want to show you how a later lab will help us with something like this. So switch back over. Okay, I did get another question on what's the difference between find and locate command. So there's a couple differences with locate. It's essentially it's kind of getting a database or indexes all the different files, and it'll show you more of the path. So for example, if I would have done locate PS, it would show me the full path of anything that has PS in it. I tend to use locate when I'm looking for binaries, or I want to find like where. A good example is where is the file tool. So if you just type out locate and then file, it'll give you a long list of them. But if you narrow it down, it shows you where the file tool is located on the file system. So typically with certain tools, I'll use that. But as far as finding a specific file, I absolutely use the find command because you can get really granular with that. Okay, and so the instructions say to change directories to home, and then the Mike Wiley, and then lab files. And within here, we have a couple of different files, including file 1, 2, 3, and 4. And within here, I can, one by one, go file 1. So this is going to run the file tool against this. It tells me it's an ASCII file. Okay, then I do file 02. Okay, that's a zip file. File against file 03. Okay, that's a PDF. File against file 04. It tells me that this is possibly Microsoft Excel. And so there's a few different ways. Obviously, if I had, let's say, 100 of these, right? I could go one by one like I did there. We have a later lab on this, but I just wanted to show you that's the manual process of doing this. There we go. Sorry, I was forgetting my asterisk there. If I do ls with a F, or someone else pointed, thank you, file with an asterisk, I'm just basically saying anything that kind of matches this. So rather than just getting everything in here, if I get ls file with this, or with the asterisk, it gives me just the ones I'm looking at. So it excludes out these things that don't match the regular expression. So word count is the other tool we're going to take a look at. And word count will then, it'll take a look at a file. For example, I think we have an IAP file in our lab environment. And within there, it's going to then do a word count. It'll give us the number of lines and words and bytes just by default. If we use a -L as an option, it'll print out the number of lines in the file. If we do a -M, it'll print out the number of characters in the file. So this is helpful. Sometimes if I see a giant file and I want to know roughly how many lines, is this outside the normal, is this normal, etc., I can go ahead and take a look at that. So what we're going to do here, and I'll jump back and do a quick demo for you as well, but you're going to pull up the terminal in that same directory where we have the lab files. You should see a 2020 access logs. And what this is I had a, not a honeypot, but that's that training site, the Blue Team Academy for some of my students. And I basically dumped out the Apache access log. So the web server logs, I put it in that file called 2020-access_log. And I want you to tell me real quick, how many lines do I have in that log file? And then go ahead, there's also an IP list file. Tell me how many lines are in there. So if you would, I'll give you a couple of seconds and I'll demo it on my screen. Okay, I'm on the right screen here. So as I was mentioning here, this was essentially the, I can't remember which screen I was just sharing, but you can see here the 4-bar in. This is the part that I was missing in my syntax, and it was just slipping me for some reason. But essentially that just printed everything out for us. File 1, file 2, file 3, file 4, and so on. Okay, and then for the lab, the things we're supposed to do here. So if we look in here, there is a 2020 access logs. If I look at the head for this, we can see that this is my Apache logs. It's saying this IP address at this date and time requested the root of blueteamacademy.com. Here's the user agent string. Here's the next request. And this is the real log files of a public web server. Now, I could cat it out, and why not? Look at this. It's just going to go and go and go. And that wasn't too bad, but you might have a huge file, like 1 million lines, and it might take forever to go down there and view all the different lines. So what we can do is we can run word count against this file, and it tells us here, by default, it gives us a bunch of information. If I just want to see how many lines are there, I use the -L option. And it tells me that there are 114,000 lines in this text file there, right? So we got an idea of roughly how many entries we have. This is great for log analysis. If you don't know how big a file is, it gives you a good idea. The second request I had here was to take a look at the IP list file, and we could see that there's 1,000 files. If I cat out this IP list file, we can see it's just a bunch of random IP addresses, or what seem to be random at this point. Okay, so I'm going to, the next lab is around using the witch, but I think we've done enough finding, and as we're coming down the home stretch with time, I want to move on to some of the more advanced stuff. So the next one I have is grep, and with grep, it allows us, we've seen a little bit of this, it allows us to search for patterns inside a large volume of text files. It takes the pattern you're looking for as an input, You can search for specified particular patterns. For example, we can use this in a couple of different ways. I can search for case sensitivity, in case sensitivity, etc. Let me just look real quick at the top of the 2020 so I can give you an example here. So if we're looking for something like login, maybe this one, what I can do here with grep is that I can use the grep tool and I can search for, I'm just going to do I for case and sensitivity, and then login is our keyword. And then we're going to do that against this 2020 file. And you can see here, it's identified, basically filtered out only lines that match. So a line is this whole thing here. It's going to match, and it found the keyword login. If I would have, just to demonstrate this, if I don't do case insensitivity and I type a capital L, we can see that it only found certain ones. Those other ones we just saw were missing, right? But if I do, it doesn't matter if I have uppercase, lowercase, or I've got here a capital G, capital N, whatever it is, it's still going to find these because we're case insensitive, right? So grep gives us a lot of ability to use regex, case insensitivity, reverse matches. So for example, if we want to find every entry that does not include login or does not include something, we can use a -V. It's an absolutely powerful tool. Okay, let's look at the next one here. So the lab that I want you to do here and kind of walk through this, just for the sake of time, I do want to give a little bit of a demo here, is we're going to take a look at the Etsy password directory. And this is the reason we're looking at this is it's globally readable and you can play on this with any Linux system. And what it's doing is you've got the user, you've got an X here for what used to be the password, the user ID, I think the group ID, I can't remember what this part is, something about the group. And then you have the shell that user is using in their, this is the home directory. And then here you have the shell that the person's or that user's using. So what we can do here is we can obviously just use grep by itself, but what I'd like you to do is learn how to pipe things through. So use cat to display it like I did on the screen, and then go ahead and use grep on top of that to go ahead and look for things like, I'm not going to do the one that's in the lab here, but if I'm looking for something like user one, I can grep that out. And now we've identified just users that have user one in this Etsy password file. Okay. And then the other piece, that's pretty much what I want you to do. So I'm going to go switch back to the slides here. Let's look at the cut. So this is probably one of my favorite tools as well. It allows you to print selected parts of a file. We can use the -D for a delineator, which basically means how are you breaking up the file. If you could imagine, you essentially take a look at whatever you're printing out on the screen and you look at it as if it was a spreadsheet, like a Microsoft Excel file. And how would you break that up? How would you define what was in each cell? That's what the delineator is. And then the -F defines the fields or the columns that we want to select. So for example here, I'm going to switch back over and give you a quick demo on the VM. So we've seen this here, the Etsy password file. And if we can see this, the delineator seems to be, at least in this file, it seems to be a colon here. I can see that breaks up the user, what used to be the password, the user ID, the group ID, etc. It's all broken up here by column. Those are the different fields. So what I do here is if I was taking the output of cat, I can pipe it into cut. And I could say the delineator is a colon, since we've seen that before. And the field that I want, so for example, if I just want this first field here for the username, I would do field equals 1. If I want to look at that second one, which is just going to be an X, but the second field, or the third field, or the fourth field, or the fifth field, and so on, right? This basically cuts it up and shows just what I want there. Now, you can also do multiple fields. So if I want, for example, for these users, I want to get their usernames and which shell that they have. I could do field 1, and then this is 2, 3, 4, 5, 6, 7. So field 1 and 7. So I would cat this out. I would pipe it to cut. Delineator is a colon, and fields, I want 1, 7. And now we have all the users and the shells for each user. So we can really just extract the information that we want. Okay, and then let's see the next piece I give you. So I kind of just walked through in the next lab is basically what we just did there. We've already been talking about piping, so I won't go into that. I do want to mention sort here. This is another great tool when doing log analysis. With log analysis, or when I'm looking at any file here and I've got a lot of information, we can use sort to do a couple of different things. We can obviously sort it alphabetically. We can sort it by a numeric value. We can sort reverse order. There's a bunch of different ways we might want to do that. So I think I've got a lab here. Let me look at my slides. The one piece I do want to mention about sort, though, is when we look at stuff, and if I essentially on the screen here cat out Etsy password again, and we'll see that it seems like it's probably sorted here by the user ID is what it looks like, 1, 2, 3, 4, etc. If I want to sort here by the alphabetically, what I could do is I can pipe the output of that out, sort, and we could see now that it looks like it's more of alphabetical here. If I go back to the top, all the A users at the top, and at the bottom, we've got the www data user. Okay, the other cool thing is if I want to sort by a specific column, what I can actually do here is I could pipe it to cut and grab what I want, but I can actually use the T, which is, I know it's confusing, every tool is different, but the T is what is the delineator. So in our case, again, it's the colon. And then K, we can say which column we want to sort on. So in this case, let's say we want to sort on the user ID. Okay, and we can see when I do that though, what happens is when I printed that out, let me give a little bit more room here. It didn't understand properly. 0's at the top, and then it goes into 1001 and then 10. It doesn't understand that these are numeric values, right? If you ever try to do something in coding and you're like, wait a second, but 101 is definitely smaller than 10, it doesn't understand that. So what you might have to do with some of these is that you also use the -N for numeric. And why did I not, once again, a demo today. Numeric should give us, or tell it that it's a numeric value. And you'll see, if it doesn't work right now, we don't need to figure it out. But I will show you a demo where we absolutely have to do a -N when we're looking at counting log files, and it'll make more sense. Okay, now unique. So what unique will do is it will compare one line of a document to the next line of the document. I do have to bring this out. I do want to show you where this can be a little bit confusing, and a demo will make this the most sense here. So if I do cut and we do a delineator on a colon again, and we do field 7, remember this is just going to give us all of these all of the shells for each user. Now, if I do, and I want to just point this out before I do the next piece. So if I look at this, we see that I first have bin bash, then I have user sbin, no login, no login, no login, then I have sync, then no login, no login, no login, right? So you can see that there's 3 no logins followed by probably 15 no logins, and then there's a false, and then more no logins, false, no login, false, no login, and then a couple bashes down here. Okay, so we'd expect we can kind of get an idea of ballpark of what it's going to look like if we try and count on how many unique values there are. But the weird part is, and this took me a little while to get used to, is if I run unique here, and with a -C, we'll do a count of the number of instances. Look at that. Why is it counting bash as 1, but then bash is 3 down here? Then I have no login as 3, and then no login is 25. These are identical, but I'm doing unique, and it's telling me that there's a count here and then a count here for the same thing. It doesn't make sense. Unique will compare one line of the document to the next. So what it's doing back, if we scroll up here, is that looking at this, it's taking this. It says, is this first line the same as this? If not, count this as 1 and count this as 1. Now compare this line to this line. Oops, let me try and get my mouse. Those are they unique? If so, now make the count 2 for this. Compare this line to this line. Are those the same? If not, now the count is 3. Compare this line to this line. Are they different? Yes. So the total count of these are 3. This one's 1. Now, is this line compared to this line? Are they the same? No. Okay, start the count as 1 for this. Now, is this line the same as this line? they're the same. So now the count is 2. So it's only comparing line by line, not the entire document, which could be a little bit confusing. Okay, so that's why our numbers are all messed up here. Even though this is identical, and it's got a count of 3 to this, 25, it didn't add them together because it's looking line by line. So in doing so, this is where we might have to then pipe the output of this to something like sort. Now, if I just do sort by itself, though, I still have a similar problem here. I'm still seeing some things that are kind of the same, some that aren't. So what I might want to do first is that I may want to do a sort before my unique. So let's back up a little bit. Let me now first, instead of unique, do a sort, and let's see what happens. Now, if I scroll up, we can see that all the bashes are together, the falses are together, the no logins are together. So if we try this again, and I now run unique C, let's see what happens. Much better. So now we've got 35 for no logins, 1 for sync. Make sure you don't make this mistake, because I've done this on a log file where there was many options and I didn't realize it wasn't so small where there's only 4 options. And I've made big mistakes on the number of bad logins and other stuff like that. So make sure you do a sort first. The other thing you're going to see now is, though, wait a second, bin bash is 4, then I've got 3, then 1. What is the sorting? The sort is all messed up now. I thought I had sort. Well, you sorted first, then you did unique, but now it's just doing it based off of how it saw it. So if we really want to now sort by, let's do a long tail analysis to see the most occurring event or the least occurring event, we have to do one more sort here. So sort, and if I run this though, wait a second, it still doesn't make sense, right? Now I've got 135. It doesn't realize that this is a numeric value, right? It thinks that 3 or 35, it doesn't quite get this, and it's not quite getting it properly. So what I have to do is -n for numeric value, and now we see 1, then 3, then 4, then 5, and it's numerically sorted. Now, if you say, well, I don't care about the 1 occurrence, I'm more interested in the least occurrence, or sorry, not in the least, I want to look at the most, and obviously you can see it here on my screen, but what if you're dealing with log files where you have thousands of user agent strings, and you want to see the most occurring? Well, we just do a -r for reverse sort, and now we've got a reverse numeric sort. Okay, cool stuff. That took me a while to get, but I use this all the time now with log analysis. Okay, so now let's take a look at sed. So sed will allow us to manipulate each line of a file or string by replacing specific or specified parts. It's used heavily by users that deal with large volumes of text and need to change them on the go. So let's go here. This is a lab that I have, and I'll give you just the demo of this on the screen. So what I'm telling you to do is that you're going to change directories into home, the Mike Wiley lab files, and you're going to go ahead and run head on the IP list just to see that it's a bunch of IP addresses. We already did a word count on this so that we could see that there was, 1,000 different IP addresses in here. And fun fact, I actually use sed to randomly generate all these IP addresses. So they're all random, there are no client information or anything like that. What I can do here is that, let me look at the next step. So the next step is that I want you to grep for any IP addresses that start with 172. So we can see that I've got 170, 226. I want to start with just 170. So we're going to go ahead and cat this file out. We're then going to pipe that over to grep. And if I do 172, see what happens? It searched literally for 172, but I wanted to search for things that start with 72. So I want these two to appear, but I don't want this one to appear. I don't want this one to appear. I don't want this. I just want to start with 172. So if you remember from our regex, if I use the up arrow or the up caret, I can't find that on my keyboard. There it is. That gives us just IP addresses that start with 172. So we're able to pull that out. Okay, so now we can also, just for fun, do a word count to see how many of them there are. Great, there's 7 that match the answer key, so we're good to go there. I then want you to replace those. So when we see the 172, I want to give this out. Let's pretend this was not randomly generated IP addresses, but this is my internal IP, and I want to post this on Spiceworks forum and ask questions about this, whatever I'm working on. And so, but I don't want to give away my internal IP address. So I want to X those out. Obviously, it would be very easy to just one by one put X's instead of the 172. But on a large scale, when you're dealing with I've done this for my students. I found an actual incident at our client. They were breached. Or not really breached. They were almost breached. And there was a lot of brute force attempts. I had 10,000 log files, and I wanted my students to see a real brute force attack and what it looked like. But I didn't want to give out client names, IP addresses. So I used this exact trick here to take the output of those 7 IP addresses, pipe that through to SED, Stream Editor. And what I can do here is that I can basically say, look for 172 and replace that with whatever I put here. So in our case, we would just want to put X's. And I want to do that globally. So now, anytime it finds 172 in our results, which is all these ones in red here, it's going to go ahead and replace them with all X's. Great. So now we've got these X's here, and we're not giving away our IP address. Okay, same kind of thing. I could even say, the one other thing I do want to mention though is that it's made this change just in the standard output. If we go back to the original file, this is going to be the original amount. So you may want to then pipe this out to IP safe for whatever else, and now we've got a list of those IP addresses. But it's only going to change that in this view here, the standard output. We'd actually have to now look at, and we can even see if I go back here and I look at this list, it still has the IP addresses. So again, just keep in mind that we're making that change on the standard output. We're not changing the original file there. Okay, so now the next thing is that, okay, we've got these IP addresses that we just put into IP safe here. If I cat out IP safe, we can see that they're deneutered there, I'll call them, or defanged. And now I want you to essentially change this, or I want you to add HTTP in front of it. So what we're going to do is that we're going to use SED again, and we're going to prepend in the beginning. Anytime, so at the very beginning here, where is my up arrow again? We're going to put HTTP : and then I want to do // but it's going, those are special characters. So I have to use backslashes to escape out of that. And then I want to use G for global, right? And so now this should, if I did this right, it should give us HTTP : / and then it'll give me those IP addresses. Perfect. So I'm able to now add those in as links. But, and similarly, we could have done this for our full IP list of the 1,000 files here, and we can see that all these are now HTTP : // But what if these were, and see how I can almost click on these, and if I click, it may even open. These are bad IP addresses. Maybe I got these from my intrusion detection system, and I don't want people to click on them and accidentally infect themselves. So what I can do is now that I have this, and let's even dump this out to a file called http.txt. So now we can just look at http.txt, and we've got our IPs there. Now I want to defang these. So we can go a step further and say, well, let's change now HTTP to HTTPX. So I defang them so people don't accidentally click on them. And again, look, when I kind of hover over this, it knows it's a hyperlink there. Whereas if I use SED and I say, anytime you see HTTP, replace that with HXXP and do that globally, what should happen here is now we've got these links, and look, they're no longer links, essentially. It's not recognizing it as a hyperlink. I can't click on those anymore. So I've now defanged these and made them safe to share with my team. Again, this is doing it on the standard output. So if I want to save this somewhere, I probably want to call it something like defang, something like that. Okay, and now if I look at my HTTP list or my .txt file, it's the original. But if I look at my defang list, these are the ones that are defanged, and I can't click on them anymore. Okay, we're wrapping up here with time, so I do want to show you just a couple other things here before we have to call it a day. Like usual, my workshops always go over and I never cover as much as I want. So the last thing here I probably want to show you is awk or gawk. It's pattern scanning and processing language. It's kind of like SED, but awk has a lot of other useful features. It can do things like grep, cut, cat, etc. The -F switch or option allows you to find delineators, kind of like we saw with cut or SED. We can also print text. We can print then the first column, second column, etc. And so to give you kind of a demo of what that might look like, if we look at our Etsy password file, if I use dash or capital F, I can find my delineator. And we remember it's a colon. Then I print out in squiggly brackets here, print. What do I want to print out? If I do a $0, that's going to be everything. And it's going to act in this case kind of like cat.
And you said I was not going to be useful. See, I was useful.
Yeah. So now I got this, but obviously this piece, the delineator didn't really matter when I'm printing everything. If I do a 1, that's going to be just the first column, kind of like when we cut up the file originally. And I could do, obviously, we know what 7 is. The 7 column is the shell. Okay, so that gives us that kind of ability similar to that. The other thing that we can kind of take in and look a little more advanced here, and this is probably the lab we're going to have to end on, is I've got for those who don't have the pre-stage stuff, you can get it off of Blue Team Academy. But for those of us who have the Mint Linux distribution that I've provided for the workshop, we've got that in our lab files directory. So in the lab instructions, it tells you to do a wget just to practice downloading that. So the wget instructions are to, there we go. Okay, so now I've got that 2020 file. If you have problems with that, it's also located in your lab folders if you're having a problem downloading it. So if I take a look at this and we use, let me just head it again. So we've got baseline. If we look at this, it looks like spaces are what delineates this, this file. And so what I'm going to want to do here with awk is we'll do capital F for delineator, and I'm just going to do quotes with a space. So the space tells us that's the delineator in there. I am then going to tell it to print $0, so everything, and from this file. Okay, and we can see it basically just printed everything, right? Just like catting it out, nothing super special. But if we look at some of these things that we might be interested in, like, oh, I might be interested in the IP address, and this would be column 1, then column 2, 3, 4, 5, 6, 7, maybe the user agent string. So if I did columns 1, let's just do 7 and 12 and see what happens here. I need $signs in front of these. Okay, so now we can see that it's giving us the IP address, what was requested or what URI was requested, and the user agent string for every request from my website, right? And so now I've got some useful information. Now, if you can think about this, some other use cases I might have of like, well, why don't we do what we did just in the last lab and now do a, let's see, we'll do a sort, right? So we got to sort it first if we want to do some kind of long tail analysis, right? So now it's sorting it out. If then I want to pipe that to unique C to get an idea of a count, okay, we get some counts there. And then let's do long tail. So let's sort it again, reverse numeric, just so we can see the top. Let me go back to the top there. Top number of hits. And actually, let me not do reverse just because it's going to, I want to see this at the bottom. So largest number. So it looks like this IP address here did a bunch of requests to the root, and we can see there's 3,419. So this might be an IP address I want to do a whois lookup or some threat intelligence. Keep in mind though, you can see here that there's the same IP address, but we're seeing that these are different URIs. So therefore it's counting it differently here. So if we didn't want that to happen, we just want to see who's the top visitor of my website. I would just look at that first field that's just the IP addresses. And now we can see 38,000 for this IP address. All right, maybe we want to look at that and we want to see, well, that IP address, and I also want to see their user agent string to see what kind of user agent string they have here. Mozilla, okay? And so you can start looking through some of this stuff and see, well, maybe you look at the long tail analysis, you look at the least used, and sometimes you can find some interesting things in here. We could also use grep. So if we go back here, we can even pipe this first out to grep, and I can say, maybe I'm looking for, let me actually do this. 0. I'm going to first just cat out this 2020 file. I'm going to grep it and look for something like nmap. Let's see if we can find that. And then let's just print out what we see here. Okay, none of those. Let's do, I can't remember what is some of the stuff I saw in here. Mass scan, maybe. There we go. Mass scan. So someone's masking my site. If I want to see, okay, well, mass scan's one thing, but how many people are, of these mass scans, how many of them are coming from the same IP address? So now we can go back and say, well, rather than printing the whole thing, let's just print the IP address and do our count here. So it looks like it's pretty evenly dispersed. If I did that correctly, as far as it was a mass scan from different IP addresses. These are the IPs that are trying to mass scan me. Mass scan's probably not a big deal, but what if it's a Metasploit module, or people are using specialized scripts or other things like that? So you can start looking for some of those hacking tools. You can filter or do sorts by user agent strings, by malicious HTTP requests. I mean, there's so many different things that you can start going through. We're out of time as far as all the labs, but this is the area where I would spend a little bit of time and start looking for some of those things, like looking for those keywords of different tools that you might know about. Let me do case and sensitivity and map, see if there's anything else. Metasploit, there's some other tool there that I'm not familiar with. Let's see if there's any curl, so you can start looking at these different tools. See if there's any scripts. Some people, those are on my website. I can look for, just trying to, middle of nowhere, think of some other things that might be out there. If there's a wget, see, you can do tons of different stuff. We can look for, there's Nicto. That's probably one I should have looked for. So this is a tool most likely used for brute forcing, tons of those, right? So that was a big hit on Nicto. So maybe now this is where I want to then use awk. Want to look for spaces. We want to print the IP address there, and then sorts, and then unique C, and then sort again by numeric. So now these are just people in their user agent strings that they've used Nicto, and we can see all the IP addresses. So these are the ones I probably want to look at, because it's probably with Nicto, it's not just a port scan. With Nicto, they're actually trying to find vulnerabilities in my website. So I may determine that I want to block these on my firewall or my WAF or other controls to make sure that they're not trying to break in. I may then take these IP addresses, copy it, grep, and just find out all the different URIs that they're trying to visit and see if they're trying to guess, sensitive directories and whatnot. So many different use cases, but this is where I'd spend a little time to play around and see some of the stuff you can find. This is an absolute live Apache web server log, and so you can see all the different things that people are doing. I mean, even look at this test. There's a test number, so someone's using this evasion technique set to none. You can learn a lot just going through some of these logs of a server that's sitting out there on the internet for some time. So in case anyone else wants to connect on Twitter, LinkedIn, YouTube, definitely, as Victor said, those who joined late, we are recording, and he'll be posting that later on. So about that, if there's no other questions, I can hang around for a few minutes for specific questions if people have them. But otherwise, again, thank you, Victor.